Start the stream. Here we go. Run over to renderography.com and get this show on the road. All right. Okay, so this week we're going to completely transition into a new topic, a new area of 3D modeling. One of my goals of this course is to expose you guys to as many different outlets of the 3D modeling art form as I can. The last couple of weeks we've been focusing a lot on product design and really starting to look at some tools that allow us to make some really compelling shapes based off some very, very simple primitive profiles. Well, today we're going to change gears a little bit and start talking about architectural visualization. The arcviz world has taken, or let me rephrase that sentence, the 3D modeling industry has taken the arcviz world by storm. Over the last couple years, the architectural visualization community has really exploded inside the computer graphics area, and I think a large part has to do with the prevalence of Moto and the awesome tools that we now can use to create these really stunning images. I think there's no better fit for Moto than the architectural visualization world. It really is a perfect tool because it allows us to work with a high degree of accuracy. We've already experienced to some capacity the working within the common measurement system within Moto, right? We can do things in feet and inches and millimeters and centimeters. So we have the accuracy that the CAD guys are often forced to work within. Well, most importantly, we have a workflow that allows us to create some really amazing images. This images comes from Mike Mitzink, a fantastic professional in the Moto community, doing some really amazing work. Here's another one, fantastic Moto rendering. So why would you think that the architectural visualization world has been so attracted to working inside of Moto and using it as a tool? Why? It's easy, definitely easy to make these renderings. I think if you look at the historical context, in the past, it's very, very, very difficult to make something that looks like this. It would be very expensive. The software that was required was incredibly expensive. And now, so Moto has brought the price point for these renderings down much, much, much lower. And now the small to medium-sized design studio, the architectural studios, can afford to do these types of renderings for their client work. Okay. Why else has the architectural visualization world just kind of exploded? Yeah, we can do photorealism. We can do photorealism. If you've ever worked with a CAD application, the one thing it doesn't do is rendering. It does a really great job of fleshing out the forms and the shapes, but they don't do a really great job at rendering. Okay? That's where Moto really comes in, is that we do a really great job at rendering. We can very easily achieve that level of photorealism. And the technology has gotten to the point where we can now bridge the two worlds much, much easily. Okay? Using open source file formats, we can take the actual CAD file that these architects and engineers are using and then bring them over into Moto and create our final renderings. Okay? Gone are the days where you had to rebuild your entire house in Moto, or any app for that matter, to get a really good rendering. Now this is a pixel-perfect, precise representation of what that building is going to look like. Also, the architectural visualization world is a fantastic application of this entire workflow because it allows us to ideate, it allows us to iterate very quickly, it allows us to go through the iterative design process and make changes. It's a whole lot easier to move a digital wall than it is an actual wall, right? So this is a good tool for us to conceptualize what the final form and what the final layout of these buildings are going to be before we commit to actually breaking down walls and constructing buildings. Okay? We have the pleasure of living next to a construction site for the next year and a half, and it's going to be a fantastic journey as we see this building be built right in front of us. Hopefully you guys, I don't know, have you guys seen the drawings for the building? The visualizations of the drawing? It's going to be a cool looking building. To get to this stage where they're physically, they've done the foundation, they're about to start throwing in the superstructure and all the steel beams. There's a lot of design work and visualization that needs to happen before they can even, roll in the first bulldozer and start making that building. This industry is a perfect application of these 3D tools. Okay? So this week's conversation is going to focus around the architectural visualization industry. We're going to look at some new applications of some old tools. We're going to revisit the pen tool again, talk about the wall mode a little bit more in detail and how we can use it for architectural visualization. We're also going to explore the snapping system in detail, as there's some really good things in there that make this important, or make it an important tool in this workflow. And then we're going to wrap up our conversation today by talking about Booleans, okay? And Booleans are a fantastic way for us to make holes in things quickly. For example, all of our walls and doors, or excuse me, all of our walls are going to need windows and doors, right? Booleans are a fantastic way for us to quickly, and I mean quickly, establish all of those pieces of geometry without a lot of effort and the accuracy that we're going to require. I'm also going to sprinkle in some moto goodness, talk a little bit about the work plane, talk a little bit about the snaps and precisions palette, and kind of round out our toolbox to allow you guys to make your first building. With that said, the homework this week is going to be a two-parter, kind of like our cork board. So if you take a look-see at it, you're going to be making your own building, okay? Your own building, your own house. There is no reference. I'm not giving you any requirements. You can do whatever building you want to make, okay? And did anyone recognize the building as the featured image? Yeah. Dun, 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 dun. So you can make it whatever building you want to make. Doesn't matter to me. It just has to be the exterior. We're not doing the interior of the building. We're just going to focus on the exterior of the building. If you have some extra time, once the exterior is done, go ahead and start fleshing out the interior. If you can see it in the render, it's a cool detail to add, okay? But this week, we're going to focus on making the exterior. We're also going to focus entirely on making just the geometry for our building. So this is going to be a two-part project. This week, we're going to focus entirely on the basic construction techniques for creating the shape. And then next week, we're going to talk about the rendering stage and the texturing stage to make our building come to life. Through that conversation, we'll work with some UV maps, some unique projection types, and also explore the art and application of tiling textures. So we have a lot to cover over the next 2 weeks. Okay? Kind of makes sense? Two-parter. Geometry this week, textures next. All right? We'll come back to some of these details a little bit later. Our lab assignment this week is going to be a fun one. I'm going to force my hand. I'm an old school modeler, as you know, and I truly believe that if you're not modeling to reference, you're modeling wrong. So I'm going to force you guys to go out and do a little research. Everyone in here thinks they know what a building looks like, right? Until you're actually armed with the challenge of making that building, and then the result gets a little funky pretty quickly. In order for us to achieve that realism, the accuracy that the render desires, we have to base our entire work this week on reference, okay? How do windows look? What are the moving parts? What does a door look like? These are all answers that are going to be achieved or all questions that are going to be answered through your reference research that you're going to do this week. So you're going to be going out, collecting some images, archiving those images in a zipped file, and submitting those to the Dropbox on D2L, okay? We'll talk a little bit more about this as we get closer to the end of class today. All right? Pretty cool? Excellent. Excellent. All right, so let's jump in and start exploring how we can participate within this lovely, lovely, lovely world of architectural visualization. Okay, let me get rid of all my mail here, excuse me. All right, I want to create a new project file here in Moto. We're just going to zip over into the Model tab and use this as the foundation for everything that we do today. Okay, so last week we talked a lot about making curves because we explored the process of using these curves to generate a radial sweep function for our little medicine bottles, right? Well, this week we're going to expand upon the application of the pen tool. Last week the pen tool allowed us to create some really unique custom shapes that match the profiles of both the goblets, the glasses, and that little medicine bottle that we crafted. Well, this week we're going to look at the pen tool through the lens of architectural visualization. The pen tool has a lot of really neat features in there that make it really predominant in this workflow. Check it out. Let's go ahead and start using the pen tool here. I'm going to the basic tool tab, and this button right here is home to my good old pen tool. So let's check it out. I want to zip over to the top perspective of my scene momentarily. Here we go. Just so it's a little bit easier to understand how the pen tool is working. I've noticed that when you're working with the pen tool, being in an orthographic viewport is probably a good idea. You're going to get a much more predictable result. Your brain is going to be able to decipher and kind of decode what it's doing easily in the orthographic viewports with the pen tool. Okay? So right now, if we look at the way the pen tool behaves, simply single left clicking inside the viewport, oops, let me turn this off. Single left clicking inside the OpenGL viewport is going to allow us to create these really custom shapes, right? Pretty rad. This came in very, very handy last week when we were generating our profiles. But what this doesn't give us is a little accuracy. It doesn't give us the control that we need to make some very, very discrete and defined blueprints, okay? I basically want to create kind of like the footprint of our house. We can do all this with the pen tool, and I think I showed this to you a little bit last week. There's an option inside the pen tool that makes it amazing. I love this option, and it's called the wall mode. With the wall mode off, this is the function that we're going to get, right? We can go, it's just custom shapes, custom shapes. At the conclusion of every pen tool operation, we're always going to get polygons, okay? But how we use those polygons is kind of a little bit of a trick. We can't use this polygon for architectural visualization. It might look like some of the areas of my little footprint here are even and kind of generally the same, but it lacks a certain consistency across the entirety of the surface. So this is out. Architects, they like consistency, right? They have to measure things beyond any reasonable doubt. There are city codes and building ordinances that determine how thick the walls are, for example, and how high certain things need to be, and how steep your roof can be. So there needs to be a certain level of precision all across the mesh here to work in the architectural visualization world. You're going to see me talking a lot about precision today. Moto allows us to very easily be accurate with how we model. So let me show you some ways that we can be accurate. I'm going to use the wall mode in conjunction with the pen tool. Let me get rid of this abomination of a shape. Here we go. I'll refire the pen tool, and this time I'm going to turn on the wall mode. And just as a refresher, you can find the wall mode in your pen tool options. So here we go. Wall mode. Right now I have it off, but we're going to turn it to inner. I'm going to show you the differences between inner, outer, and both sides, but let's just explore what this function, or how this function is going to change the behavior of the pen tool. We're still going to be able to throw down custom vertices and control points along our shape. Okay? This offset value is a thickness. I'll come back to that in a minute. Right now it's currently at 6 inches. But watch what happens when I start throwing down the points. I click once, still get a single control vertice, but now when I click twice, check it out. I've created a strip. If I click a third time, you can see what I'm creating here. Something kind of like that. All right, let's talk about what just happened here. The computer is doing a couple things. It's automatically drawing a quad strip based on the location of those control vertices that I've thrown down in my scene. The offset value is determining the thickness of that quad strip. So this number right here plays a really important role. If that offset value has a value of 0, you're not going to get anything. You're just going to get a solid line, and it's not going to work the way it needs to work. Okay? This is dangerous. This is dangerous. Whenever you're using the wall mode, make sure there's a number in there. And it has to be a real-world number. You know, we're establishing the true thickness of our walls. Right now, if you look carefully, that's 6 inches. So I know beyond any reasonable doubt that the walls that I've created are 6 inches wide. Okay? That's actually an important number to keep in mind as we work through this entire process, because if you're working with an architect, you need to figure out the dimensions of his walls or her walls, okay? Because there are ordinances that determine how big the exterior walls are in comparison to the interior walls. I think if I remember correctly, exterior walls are required by code to be 10 inches thick, and then interior walls, so like this wall right here, would be 6 inches thick, if I remember correctly. Come on in. So we get to change that. While the tool is still live, check it out. I can change that value, and you can see interactively that the tool is going to update and respond. So the moment I mouse up, now each one of my walls is 3 feet, 8.625 inches. So they're really, really big. They're really, really big. So we can change that, though. Maybe I want to put them back down to 10 inches. So we'll do 10 inches. Boom. Now they're 10 inches. Now, where those walls are being generated and the rays that are being cast out from those control vertices is determined by which wall mode we use. At the current settings, I'm using the inner mode, right? Look carefully at how or where my control vertices are in comparison to that exterior, the exterior of my wall. So I got my control vertice here, and it's generating an edge segment that's going out this way, and then we hit the wall, okay? That's in the inner mode, so all the control vertices are in the inside of our building. If we were to flip this to outer, you could probably imagine what would happen. Boom, the opposite. Now all of our control vertices are on the outside of our walls, and the thickness is being cast to the interior of our building. Okay? So pretty neat. So now, if we look carefully at what we have, it's 10 feet from this dimension in here. The both sides mode here in the pen tool, it's going to allow us to do that. Okay? Now, if you look very carefully here, check this out. Let's go to both sides to outer. Is the size of this wall 10 feet? No, it's 20 feet. That's an important thing to remember. When you're using both sides, it's 10 feet on either side of the control vertice, okay? Or, excuse me, 10 inches on either side of the control vertice. So keep that in mind. As a habit, I kind of almost never use both sides. I'm an inner guy, okay? I'm an innie, not an outie. That was a bad joke. So I like the inside. That's just it makes it a little bit easier for my brain to decode how this building is going to be constructed. Okay? Pretty cool, huh? Pretty cool. When we drop the tool, we lose access to all those control vertices. So make sure that you have your building kind of dialed before you drop the tool. Okay? That's kind of the big landmine that people step on when they're using the pen tool, is that they accidentally drop the tool. You hit that space bar, all this lovely magic that the pen tool creates is gone, okay? And what you're going to be left with is just some standard polygons, okay? Drop the tool, and now I just have standard polygons. Standard polygons that I can do, I can bevel, I can do whatever I want with them now, okay? Let me show you a couple other features inside the pen tool that are really important to point out. One, and these are standard pen tool features, not necessarily tied to the wall mode. The one that I want to focus on is close. If close is active, what you're going to create is a closed loop of polygons with the pen tool. So if you look carefully here, as I click around my scene, the moment I lay down that third control point, the computer is automatically going to determine and figure out how it needs to create a polygon to connect the dots between that last control vertice and the first one that I created. If this is off, that's what you get. Okay? It's going to be an open loop. For our blueprints, our footprints for our buildings, you want to make sure that's not set to close. That way, your building is always kind of watertight. All right. Pretty great, huh? Love it, love it, love it. A lot of fun. The pen tool is going to give us a certain level of accuracy. However, one of the things that we haven't really had, one of the elements of accuracy that we haven't really achieved yet is being able to create like 90-degree corners, right? Architects are all about angles, man. They like to have, it's important for them, I don't know, for our walls to be kind of level, right? 90-degree corners or at least angles within the house that are defined and known, okay? That's an important detail for an architect, believe it or not. So we want to be able to tap into that system. We want the pen tool to help us create 90-degree corners or defined angles quickly while we're creating the walls. We don't want to have to do it after the fact. We want to do it while we're creating the walls with the pen tool. Because those control vertices are cool, man. They allow us to very quickly make some custom shapes, but we need some accuracy. If you look carefully, the foundation for what I'm talking about is visible when we're using the pen tool. Check it out. If we keep cruising down, we have this pen snap section instead of our wall mode or our pen tool options. And right now, you can see all the snapping options that are available to us, but they're grayed out. So what does that tell you? They're not on, they're not active. We need to activate them. In order to get the world axis snap, the straight line snap, there's an idea. How about some straight lines? Woo! Okay. And then most importantly, the right angle snap, we need to activate the snapping engine inside of Moto. Now the snapping engine is a really powerful feature inside the Moto toolbox, okay? It affects everything in the application, so buyer beware. Once you turn it on, all of your tools are going to access the snapping engine, okay? It's kind of like fall-offs and action centers and a couple other things. It's a global operator that's going to affect everything. The way we turn on our snapping engine is really easy, okay? Most people think that this is the way to turn it on. No, we're going to come back to that, okay? The way we turn on our snapping engine is up here at the top of the screen. Check it out. Snapping. This is an on-off button. It's a toggle. It's either on or it's off. Right now it's off. We know that because we don't see the highlight color. But the moment I click on that button, boom, the background goes kind of orange. And now the snapping system has been enabled. It doesn't look like anything's changed with inside of our interface, but if you look carefully back at the pen tool options, check it out. Aha. Now our pen tool is giving us access to all three of those snapping tools, okay, the snapping options inside of Moto. So check it out. Watch what happens when I use the pen tool now. The tool is going to work in conjunction with the snapping engine, and it's going to allow me, okay, look, see, you see that? Boom, straight line, snaps down. Just trying to snap it into a straight line there. Boom, cool. Now the location of that control vertice is at the exact same position along the z-axis as that one over there. It's a little difficult to see, and I apologize. On this projector, it's kind of hard, but if you look very carefully, look in that corner up there. Can you see that little purple right angle indicator? The little square? Can you guys see that? Yeah, that's going to show up. I can't walk away. It's something that you're only going to see while you're mousing down. So right now, I have my mouse clicked. Okay, and that's going to give you a little indicator representing that the angle that you've created there is perfectly 90 degrees. All right, look at this. Okay, this is the straight line snap in action. Can you guys see that little purple cross immediately to the left of my yellow control vertice? That's telling me if I put my control vertice right there, it's going to be in the exact same location along the x-axis, so left and right, as control vertice number 1. So it's yeah, there it is. Now I know beyond any reasonable doubt that those two elements are lined up precisely. The snapping engine inside of Moto, in conjunction with the pen tool, is going to give us the accuracy that we need to very, very quickly make good buildings, okay? And I love it. It's fantastic. It's really quite good. Really quite good. All right? Keep an eye out for all those little purple indicator lines. They're going to help you figure out where you need to place your control vertices to get you the angle that you need. Now check this out. This is also kind of cool. So I just put my mouse cursor there. It automatically snapped to that location, and it's telling me that if I made, if this was a closed loop, I would create a 90-degree angle right now going, oops, I moved it. Sorry. There we go. And if it's closed, boom. This line right here going that way is 90 degrees. Awesome. Awesome. Okay. Really good. Really, really good. I like this a lot. Makes working inside of Moto extraordinarily easy. Yeah, there's that right angle indicator again. So this angle right here is 90 degrees. It's just so cool. So keep an eye out for all of those small purple indicators. They're going to help you figure out where your angles are and if your lines are in fact straight. It's an incredibly powerful feature inside the pen tool. Okay? I love it. I love it. All right, at times, however, we want to change the way the snapping engine works to yield us some more precision. With the default snapping engine just enabled, you can see the result that we're getting. However, maybe I want to snap some points to my grid. Maybe I want to have a couple of these control vertices be precisely at the center of the x-axis, okay? Or maybe in a very specific location within the scene. Using the grid is a powerful, powerful power enhancement to the system that we're working with here. But in order to get this level of control and to use the grid, we need to kind of enable that feature in the snapping options. So we have two different levels that we have to work with. We have the global snapping engine, which is a toggle. It's either on or it's off. So if I was to go back up right now and just hit that snapping button again at the top of the screen, boom, now the snapping engine is no longer being applied to my system. I'm no longer getting those awesome snapping guides here in the pen tool, okay? You can turn it back on while the tool is still active, by the way, and continue working, which is pretty neat. I love that. Okay, so the snapping engine is a global tool. It's either on or off. But we can also change its behavior by going into its snapping options. And that's what this button is, right here. This button is going to give us all of our snapping options. Keyboard shortcut F11 if you're a keyboard person. Okay? And if you click on that button, you're going to get this cool little flyover. And let's go in and take a look. We're not going to go through all of these today, but I do want to draw focus to some rock stars. Certain options in here that will allow us to gain a high level of accuracy within our model. Of course, right now you can see that the snapping engine's enabled. And if you don't see any of these options in here, so any of these guys, if none of them are kind of gold and selected, it's basically saying that we're snapping to none. Okay? We're not snapping to anything in particular. We're not asking the tools to snap to an existing piece of geometry or a location within the scene. Watch what happens to my tool when I change my options to snap to the grid. Yeah? You don't see anything. Let's check it out. What computer number are you? Student 11. Let's check it out. Ah, yes. Hit the snapping button. No. See where it says snapping, the little button right at the bottom there? Yeah. Right there. Click on it. Boom, there it is. You got it. Click on the wrong one. No worries. It's all good. All right. So I've gone ahead and I've changed my snapping options to tell my tool to snap to the grid. Now watch what happens to the behavior of my tool. Do you guys see that little dashed yellow cross at the center of my control vertice? That's the snapping engine. And what we're doing here is we're asking the snapping engine to analyze the location of all of our grid squares and only place my control vertice at the intersection of any one of those grid squares. Okay? This allows us to very quickly flush out locations, along our grid. I like doing this. Very handy, especially when we want to have certain parts of our model be constrained and automatically created at the center of an axis, X, Z, Y, whatever you want to have. Okay? It's an incredibly powerful tool. It's not the only component that we can snap to within inside of our moto system. Check it out. If we went back into our snapping options, if you start to peruse this list of snapping modes, you can kind of get an idea of how deep this snapping system can go. In addition to being able to snap to the grid, we can also snap to specific pieces of geometry in the scene. Wow, okay, that's pretty cool. And then we can choose which component within that piece of geometry to snap to. So we can do vertex snapping and edge snapping, or maybe we want to have two polygons be in the exact same location. Well, I can snap to them if I choose that polygon option. Let me show you what I'm talking about. Oftentimes when we're working with an architect, we'll get a two-dimensional drawing of our building, and it's our job to create a three-dimensional version of that object. All right, I'm going to create a new mesh item, and in this mesh item, I'm just going to create a Bezier curve. I'm going to keep my snapping engine on, and I'm going to use the grid snap just to allow me to flush out some very specific shapes here. There we go. And I'll choose close just to put it in there. Voila. Go. Let's just do that. Just so I have something kind of angular. So maybe this, what you're seeing here, this curve represents the front elevation of the house, okay? Or maybe this is the wacky blueprint, the footprint of our house, okay? Well, at the corners of each one of those, at the corners of this curve here, there's a whole series of vertices, right? I need to create a three-dimensional version of this two-dimensional image, right? I can use my snapping tools to give me the accuracy that I need to recreate that curve using the wall mode. Let me show you what I'm talking about. I'm going to create a new mesh item. You want to make sure if you're snapping to existing pieces of geometry, best to do it when you're on separate mesh items. Create a new mesh item, and in this new mesh item, I'm going to fire off my good old pen tool. While my snapping system is still on, and I know it's on, I want to ask the snapping system to, let's do a little vertex snapping. Okay? There we go. And now, check it out. Boom. You see that little yellow cube? That's the snapping engine placing that control vertice precisely where I want it. Okay, there we go. And there's the snap. Boom. There's the snap. And there's the snap. Within a couple mouse clicks, we were able to completely recreate that structure using the snapping guides. Okay? I know it's pixel perfect. Okay? And, maybe I can even change the wall mode to outer. Boom, and there it is. Okay? This allows us to work extraordinarily fast to create the shapes that we're after. And remember, the snapping system is a toggle. It's a global operator, okay? So if we were to move on to like the move tool, for example, without turning the pen tool or the snapping system off, check it out. I can go to the move tool. Let's select some edges here, okay? And now, boom, you see that yellow cube? That's the snapping engine trying to snap to that background geometry, okay? So it's a global operator. All tools are going to be influenced by the parameters of the snapping engine, okay? So it's not something that, the snapping system is something that we can use in conjunction with pretty much everything. Move, rotate, scale. All of our slicing tools can accept the, the inputs from the snapping engine. So buyer beware. If you turn it on, make sure you turn it off, okay? I get myself stuck in this situation all the time because I use the snapping engine a lot, and often I get so wrapped up in the construction process that I forget to turn it off. And then my tools start acting real funky, and I see things on my, like, why is this control vertice going way over there? Oh, that's because it's snapping to a vert on another layer that's way over there, and I just didn't even think about it. So buyer beware. When you turn it on, just make sure you turn it off at the end of the process, all right? All right, I love the snapping engine, and just kind of let me show you the power of the snapping engine. It's really kind of neat. Snapping engine can do more than you know. It's like a transformer, okay? It's more than meets the eye, okay? Oh, come on, that was at least a little funny, okay? I think Katrina and Melanie were the only ones that are smiling. Does that mean you were the only two that were listening? I don't know. I'm joking. Okay. Anyways, let me show you. This is something that has nothing to do with architectural visualization, but it kind of starts to show the power of this snapping system, okay? Because we can use certain pieces of geometry to influence other pieces of geometry just by this background snapping system. Let me show you what I'm talking about. Here, check this action out. I'm going to create a donut because I'm hungry and I kind of want a donut. Okay, there's my donut on that mesh layer. And on this one, I'm going to create, I don't know, how about a sphere on that one? Okay, check this action out. There we go, there's my sphere. And I'm going to move my sphere up over here, and I'm going to enable my snapping engine. And this time, the snapping engine, I'm going to snap to geometry, but I'm also going to activate a little background constraint. And let's do, I want to do vector. No, I'm going to do, I'll try point on this one. Okay, now check this action out. So I got my little donut in the background, and then I have this foreground sphere. I've enabled my snapping engine to allow me to do some really cool things. I want these pieces of geometry to snap to each other and start to influence each other in some really neat ways. Let's see, oops, a little too close. Here we go. Check it out. Isn't that kind of cool? Actually kind of going through the inside all through the snapping engine. I'm just moving it through. Let's see if I change it from point. Let's do vector. There we go. That's a better. I love that. I think that's so totally rad. And rotate it inside, and it updates. Isn't that cool? I just find that incredible. It's like you're almost like modeling with clay. The practical application of this is really quite profound. I've done some car modeling in the past, and when you're looking at cars and we were building cars, a lot of the elements that go on top of the car needs to precisely match the curvature of the hood. It's like, for example, you're doing the headlights, right? The openings for the headlights and the headlights themselves need to match perfectly the curvature of the hood, right? They need to be separate elements so we can control them independently from the base of the body. And with this snapping engine, I can very quickly, I can kind of mesh and mold my headlights to precisely match the curvature of the hood. Precisely. It's not, I'm not having to push and pull points to get it where I want it to go. This system allows me to it gives me that accuracy almost instantly. It's amazing. It's really kind of cool. We're going to talk more about the snapping engine as we get a little bit more comfortable working inside the moto system. In a couple weeks after we do this architectural visualization project, we're going to model a cell phone. We're going to model our cell phone, or a cell phone. It's going to be awesome. And the snapping engine is going to come home to roost again when we start modeling something that's logarithmically more complex. All right, so let me turn the snapping engine off and get rid of whatever that thing is. And we'll move on. Okay, so let me make a shape real fast using the pen tool. Zip over to the top view. On this empty mesh item, I'll use the pen tool. I'm going to enable snapping. So if you ever change the parameters of your snapping, just make sure you change everything back. That way you're not getting an unexpected result. Go, and all I'm really concerned about in this particular example are some straight lines. So let's do this. go. There's that one. There's that one. And shoot, let's get a little bit more creative here in the back of the house. Oops. Something that looks, I don't know, I'm just eyeballing it here. Something that looks kind of like that. There we go. That's going to be my house. Now, I just created the rough two-dimensional blueprint for my home, right? So what's the next thing I should do? Not yet. Before we even bevel it, where does this object need to be placed within our scene? The origin. Absolutely. The moment you create a basic simple shape, get it in the origin. The origin is going to give us some new options today. We're going to talk a little bit about mirroring. We're also going to revisit the role of the origin action center. We want everything to be at the origin of the scene because it allows us to be accurate. It also allows us to do half of the work because I can model one half of the building and then duplicate it across the x-axis and have the other half of the building done magically for us. I'm all about doing half the work for twice the amount of money. I love that. So we want this thing to be at the origin of the scene as easily as we can. Okay, so I'm just going to do center selected, and I'll do all. Boom. Oop, I missed it. All. There we go. And now our model is precisely at the center of our scene. Okay, so it's important for me in this particular model that we have a little symmetry on the left side of the house opposed to the right side of the house. I kind of botched the angles at what would be the back end of my house, right? That little chamfer, that little edge that's going in like this where it tapers, the angles are different. And I did that intentionally so I can show you how we can make them identical to one another. We want to work in symmetry for as much as we can. If you look around our world, most things in our world have an identical left side to the right side, okay? There's natural symmetry across our entire planet. Our home, or my home at least, is going to be as symmetrical as we can make it. Okay, so I need to fix some things. Whenever you're modeling, try to find an opportunity to create a center line in the mesh itself. A center line. Okay, so I need to slice right smack dab down the center of my geometry. How am I going to do that? Give me some options. I gave you about 10 of them this semester so far. Slice tool. I love slice tool, right? Love slice tool because it's like a laser. Love slice tool. You can find the slice tool in the mesh edit section. Here it is, slice. If I hold down the control key before I click, I can draw a straight line. Aha, fantastic. And now I've sliced my model right down the center. I have two pieces. I have the right side, and then I have the left side. What's another way that we can work? How else can we slice this object right down the center to yield a center line? Let me show you another tool that I really like working with. It's called edge slice. Kind of works along the same parameter as the slice command. It's going to allow us to get a little bit more specific as to where these new edge segments are generated. You're kind of in the driver's seat here. You can find edge slice right there. Check it out. There's a little bit of a procedure that we have to follow when we're using the edge slice command. Check it out. It requires us to begin on an edge. And you can see when I roll over an edge, it goes blue. That's what we want. If I left-click once on that edge, we get a control vertice. Now I need to slice it down over here on this edge. Boom. And you can see that I've created an edge. Okay? So we're a little bit more in the driver's seat as to where this tool is going to work. Okay? I like working with edge slice. It allows me to very, very quickly go in and throw some custom edges where I need them to be. In addition, it also allows us to control where within those edge segments those new control vertices are placed. So we can do something like that and have a really custom placement of our edge. Now, notice that the tool is still working. If I wanted to slice perhaps this bottom edge next, what would I do? How do I repeat a command inside of Moto? Shift click. Shift click. This works well with the edge slice command. Check it out. So if I hold down the shift key and then click on that guy, I've reactivated the tool, and now I'm able to, boom, slice that way as well. When you're using the edge slice tool, you're only allowed to slice between the edge that's immediately below the one that you started with or above. So you can't like skip an edge row. You got to go sequentially down that entire edge loop with the edge slice command. Make sense? Kind of? All right. Once you get your hands dirty with it, you'll find that's a lot of fun. All right. So those are two great options. Now the edge slice command gives us some funkiness. I go a little OCD with my edges. I really do. I'm both the right person and the wrong person to be a 3D modeler because everything has to be straight for me, and if it's not straight, I really freak out, and I just, it needs to be straight. Okay, it has to be straight. I can't you know, that just drives me crazy right now that those new edges are like this. So I need to fix it. Give me some options on how I can fix it. Kellen. No. You had a question? Okay, yeah.
So if you're making the shape of your house and you have edges that are jagged, how would you
center and fix them? It kind of depends. So do you have it on your screen?
Yeah.
Yeah.
Like notice how you have like it's like jagged.
Is jagged. Okay, so on Kellen's screen, she has one edge that's slightly, they're not exactly level. It's not straight. It's at an angle to each other. We're going to talk about that in about 2 seconds. We're going to come back to that. I think you're going to find the answer pretty cool. Ideally, turn your snapping system on. You should fix that. Okay, we'll come back to it though. Okay, we'll come back to it. So I need to get these things straight, kind of what Kellen has, her problem. A little bit different, but I need to straighten those two edges. Let's talk strategy, technique. How can we do this?
Just go back and move them.
Okay, we can go back and move them. Absolutely. So there's nothing that says what that I can't select those vertices down here and just move them like that. That's eyeballing it, and I don't like eyeballing it. No. I don't like eyeballing. I need precision. I need accuracy. I need to know beyond any reasonable doubt to make my brain be okay with this that they're straight. Set position. I love set position. I love set position. Now, what a lot of people try to do is center selected, right? Because they feel as though, maybe if I do center selected, they'll all kind of pop into the exact same point. And to a certain degree, you're right. But let me show you what happens. Okay, I want to get all of these things centered to each other, but I also want both of these edges centered around the x-axis. Okay. Now, center selected is a tricky, finicky little beast. Okay. For example, if we have more than one edge or more than one vertice selected inside of my scene, center selected is not going to give us the result that we want. In my screen right now, you can just barely see, and it's kind of difficult to see on the projector, the center of the x-axis, which is this dark line going down here. I want both of the vertices on my selected edge to be precisely at the center of the x-axis. Watch what happens when I fire off center selected. It's going to be kind of a funky result. So I go basic, center selected along the x. What happened? Yeah, Melanie's got it. The midpoint of that edge was centered around the x-axis, not the two vertices on either end. Same thing. So what if I changed my selection type to vertices? If I grab that one and that one, what do you think is going to happen? Center selected on the x. Same thing. So center selected is not going to give us the result that we want when we're working with more than one vertice or more than one polygon. Okay. Set position, however, is my all-star. I love set position. It's one of my most favorite commands inside the entire application because it allows us to gain the accuracy that we need to put everything at the center of the x-axis simultaneously. Okay, I'm going to do all four vertices at the exact same time. So I'm going to go grab their friends down over here. So I'm going to set the position of all four of those vertices at the exact same time. Check it out. The process to do this is really quite easy. It involves us going over to our vertex set of tools. And then in here we have set position. When you activate set position, you'll get this little popover. And what it's asking for is a value, an actual coordinate, a location within our three-dimensional space. Well, for me, I want all four of my vertices to be precisely at the center of the x-axis. So having a value of 0 feet in there is going to place them where I need them to go. 0, 0, 0 is the coordinate location for our origin, right? So if we want to move things to the origin, a value of 0 is what we want to use. Okay. I also want to choose the correct axis. I want to move my vertices left and right in this particular situation. That's along the x-axis. So make sure you're selecting the correct values for this operation. All right, the moment I hit OK, watch these two vertices up here. Bam. all 4 of those were automatically placed at the center of the x-axis. We set their position. We told them that your new home is, boom, over here. Believe it or not, this is kind of a special tool. It seems kind of rudimentary, but not all applications have this, okay? And for me, it's an invaluable part of the modeling tool set because it gives me accuracy.
Can you also do it with edges too, rather than vertices?
Absolutely. Great question. Great question. Let me hit undo for a second. So if I grab the edges, let's grab that one too. Fire set position once more. Check it out. Now really, if you think about it, an edge and a polygon are constructed from vertices, right? So the vertex set position command is going to allow us to get the exact same thing. What the computer is going to do, it's going to analyze our selection and move the vertices within that selection. So in this particular situation, it's going to analyze all the vertices that are currently associated with this edge selection and move them where they need to go. It's pretty great. It's pretty great. Okay, so I now have the right side of my house. This one, okay? But it's slightly different than this one, and let's really make it different so we can see the difference, okay? I did a horrible job with the pen tool, let's pretend, okay? And the left side of my house really isn't representative of what I want it to look like, and I need to make some changes. Well, I could go in and start moving verts around and moving edges around, but the results are always going to be poor. They're never going to be exact. I want some precision. So thus enter the role of mirroring. Mirroring is a fantastic tool. It allows us to make a copy, a duplicate of one side of our mesh, and automatically have it be generated on the opposite side of the mesh. Okay? So I'm going to start off by deleting half of my work. Those guys in there, bye-bye. Now I have half. Okay? Now I have half of my geometry. Now, much like the radial arrays and the sweeps that we were doing last week, all of the border pieces of geometry, so all those border verts, need to be precisely at the center of an axis. In my case, X, left and right on my screen. So let's just confirm this. I know from my previous operation that they're already there, but we'll establish some muscle memory. If I go in and just select all of those vertices, then fire set position, a value of 0, so the center of the x-axis, hit OK. I know beyond any reasonable doubt that all those border verts are where we need them to be. If they're precisely aligned to the center of the x-axis, the mirror tool will give us some extra love, and you'll see that here in a minute. Okay? If they're not aligned correctly, there's going to be a gap. There's going to be an opening between these two pieces. At the end of this process, I want to have one connected polygon. Okay? One connected piece. All right. Let me deselect my vertices and jump over into the duplication tab. And there it is. There's good old mirror. Now we're going to follow a very similar process that we did last week when we were working with the radial sweep. We also have done this with the radial array on the umbrella, okay, if you remember a couple of weeks ago. We're going to activate the tool, but then we want to use the origin of our scene to determine where the tool handles are automatically placed and where our geometry is going to be copied from. So I'm going to activate the mirror tool. Since everything is centered around this line within the scene, activating the origin action center is going to give us the result that we want. So now we simply left click on this part of the x-axis, boom. And you can see what the computer has done. It's automatically gone in, copied all of the polygons on the right side of my scene, and it flipped them over like this onto the other side, the left side of my scene. Once I drop the tool, check it out. Once I drop the tool, I can double click on my mesh and double check to see if it merged all those border verts. If there was a small opening, let me show you what I'm talking about. If there was a small opening inside of my piece, okay, so if it was like this, for example, okay, and I did the exact same thing, mirror, action center set to origin, boom, that's what we get. It's an exact copy on the opposite side of the x-axis, okay, exact copy. In addition, if we go the opposite direction, if all of these border verts are on this side, check it out, mirror, Action center set to origin. Click. Okay, it's going to copy everything, so we have to be careful, all right? If you look closely at the mesh, you can see that we have overlapping geometry here. There's one side, and there's the other, okay? They're not connected pieces. I just double-clicked on that polygon, and you can see that the right side of the mesh wasn't selected.
If possible, can we snap both of the polygons together?
Absolutely. So if you don't want to have to go back in and kind of redo it, there are some tools at your disposal that will allow you to do it quickly, to fix the problem. Let me show you how to do it. It's really kind of easy. It's a great tool. It's a little bit challenging to work with at times, especially in a situation like this. Here's what I would do. I would start just by getting everything where we need them to be. So I'm going to grab all of these, all of those guys, except for that one. Bye-bye. There we go. And I want to get them to the center of the X. Boom, just like that. Okay. Now, if we were to hold down our middle mouse button and select right there, hello, in the wrong component selection mode. Okay. If you look, I can't use the middle mouse button because I've got my crazy pen right now. But if you look carefully, right now I have two vertices selected. Okay. Even though it looks like only one vert selected, right? So what does that mean? There's two of them, and they're right on top of each other. They're sharing the exact same space. We need to combine them. We need to merge them. Okay. Now there's a couple different ways of doing this. Let me show you the easiest way. Okay, and it's join. Join is one of my faves. It's really, really easy to use. Join is going to take the two selected vertices and weld them together. It's going to merge them. So if I do join, you'll get this little popover that says join vertices, and I almost always leave these two options off and hit OK. And it'll tell you the product of that operation. It'll say two vertices were joined. And now if I select that, I only have one vertex. Okay. So I'm just going to go through. I have two vertices. It'll tell me how many things are selected. Join. Okay. Okay. Join. Okay. Okay. Join. Okay. Okay. Really easy. Really easy. All right. Questions so far? Everyone good? All right. So I have my blueprint, the floor plan for my house. I need to make it a little bit, I need to make it kind of 3D, right? I have some walls. That's kind of a good thing to start with on a house. Some walls. Yeah? Walls are important. So how am I gonna get this thing into a three-dimensional shape? Extrude. Extrude. I love using the extrude tool. Now I want to show you the differences between extrude and bevel. Seemingly they're going to give you the exact same result, but there's one small difference between the two. The bevel tool that we've been used to working with throughout the entire semester is going to give us the result that we're after. Fire off the bevel tool, single left click on the screen, and do a lovely little shift. Okay? Awesome. Excellent. And that's what we get, right? Looking pretty great, looking pretty great. Okay. However, if we were to look at the underside of our house, we have a little bit of a problem, right? What's going on? It's hollow, right? They didn't automatically create any polygons on the underside of our house. Now, at the end of the day, this is not a horrible thing. However, it will be kind of a barrier when we're doing like loop slicing and some things like that. So as practice, I like to have geometry down there. It just makes modeling a little bit easier, okay? Let me take a step back here for a second. Here we go. Now watch what happens when I fire off the extrude tool. And you can find extrude under mesh edit. It's right there, extrude. Keyboard shortcut, Shift X. Let me turn my snapping engine off. Shift X is extrude. Now the extrude tool is only going to allow you to draw that shape along an axis, so we can get some control here on that, which is kind of neat. Okay, oops. But what we get at the end of our extrude operation is those polygons on the bottom. Okay, so keep that in mind. The extrude and bevel seemingly do almost the exact same thing when we're shifting those polygons up, but the extrude tool is going to generate geometry on that bottom side. Okay, that's the only difference. Pretty neat, huh? Okay. Alrighty, right. Now, I'm not entirely happy with my house. If you look very carefully, these walls are precisely 10 inches thick. This is like a glorified woodshed, okay? This is not really a house. It's really not big enough for that's like a closet, the size of a closet, okay? I need a house, not the size of a closet. If you don't know how big your house is there any way within Moto to kind of figure out the dimensions of your home? How big the shape you created is? You can use the grid, absolutely. The grid is a perfect way, but that involves, I have to count, right? Pat no likes to count, okay? Because check it out. Down here, this little number tells you how big each one of the grid squares is. Each one of the grid squares is. It's 6 inches. So that means each one of these boxes is 6 inches, right? I'm not going to count and then add 6 inches. That's just way too much work, okay? Especially for me. No, I'm not doing that. Did anyone else stumble upon it? No, no questions, sorry. Okay. I'm joking, I'm totally joking.
How do you change it from vertex extrude to polygon?
Just make sure you're in the polygonal selection mode.
Okay.
Yeah.
But it's still on vertex.
Let's take a look. You're in the vertex tools. Go to mesh edit.
Okay.
That's the extrude, yeah. Okay. All right. So I want to figure out how big my house is, all right? And this is something that's really kind of important since the whole kind of theme today is accuracy in modeling, right? I want to know that what I've crafted matches the real world dimensions of maybe the blueprints that my architect gave me, okay? So check this out. It's a kind of a neat addition to the Moto toolset. If you look at the top of the screen, we have this view menu. And at the bottom of our view menu, we have this dimensions tool. This dimensions tool is going to tell us precisely how big our little object is. Okay? It's going to show you the volume of it. And if the guys at Luxology are listening, please make these letters and numbers bigger because they're incredibly small and extraordinarily difficult to read. And you can't change it, which is kind of stupid. So right now, the length of my house is 14 feet 7 inches or 7.326 inches. Okay, so it's not huge, but it's not small either. Okay, so it's going to tell you the dimensions of this entire object. Looks like it's about 10 feet wide and about 10 feet 9 inches tall. I want to make this a little bit bigger because this is supposed to be a house. This is like a room inside of the house. Okay, this is not it's not a very big room, either. Okay. I think that's roughly the size of our bathrooms here. Yeah, it's not very big, okay? So I need to make it bigger. I want to turn off my dimensions tool for the time being and look at a way for us to make this floor plan bigger. Now, I've gone through great pains to ensure that the left side of the house is identical to the right side of the house, right? Through that mirror operation. So what am I going to do? What am I going to do? Maybe I want to make my house wider, okay? So what am I going to do? Yeah.
Highlight all polygons and just scale it.
Scale it up. Let's try it. Now, where we scale is important, okay? Right now, my action center is set to origin, and you can see where my polygons are showing up, so I can scale it. But look what happens to the size of my walls. Problem, right? My walls are now different dimensions. So the scale tool isn't going to work. What am I to do? Give me some options. Boom, boom, boom. Yes, sir. I can split it in half. I like the way you think. Physically make these distances larger. Okay. We don't have to put polygons in the center. We can just move these elements around. Yeah, Alan. I love it. Okay, the move tool is definitely going to give us the result that we want. Okay, I like that. So what you guys are talking about is select like all of those guys. Just move it that way. Absolutely. And now we have a much wider house. Cool. Okay, very cool. That works as well. But now we're off center. Bad, right? It's no longer centered around the origin of our scene, right? These guys over here are kind of chilling in their original location, but I moved that right wall way over there, right? The house is bigger, but now it's not centered anymore. It's a problem for me. You know my problem with straight lines. I gotta have straight lines and I gotta have things centered, okay? Say again? Which little edges? In the middle. Yeah, absolutely. And I think I heard someone say, just do center, select it again. Okay? You make a change, center it. Center it back along the x-axis, boom. Okay? What do I need to do to that center line, these two edges in here? Where do those have to go? Set position, because we want those center lines to go back to their original location within the scene. Okay? These are the types of elements that you really need to kind of think about as you're going through the architectural visualization world. Okay? We need to have precision. We need to have accuracy. The quality of the future steps, the next steps in our production procedure, are entirely reliant on the attention to detail that you have within your scene. Okay? Good modelers, good 3D modelers are like master chess players. We think 8 or 9 steps ahead. Okay? What I do now is absolutely going to influence what I'm able to do in 3 or 4 steps from now. Okay? All right. Okay, so I'm happy with this. This is starting to look pretty good. It's starting to look pretty good. Okay. If we go back and look at our scene, let's turn on Advanced OpenGL. Yeah, looking pretty good. It seems a little squatty to me. It seems a little too narrow going this way. So let's fix that. I'm going to select all of those guys and then simply move them back. And now we have something that's a little bit bigger. It's not a humongous house, but it's not a big house either. Or not a small house, excuse me. Okay, looking pretty good. If I wanted to, I could absolutely reactivate the dimensions tool and see precisely how big my house is. So it's 25 feet long by 23 feet wide. It's almost a square. Let's make it a rectangle. There we go. That'll do. That'll do. Dimensions tool. Dimensions tool. All right. Looking pretty good. Now the last thing that I need to have here is a little bit of precision on the height. Okay? I have no idea how big this, how large my walls are, how tall my walls are. Okay? I need to get them to a very specific height. The ceiling in this room is gigantic, right? If you go home, you're going to find there's a consistent height for all of the ceilings in your home. Like in my home, I think I have like 10-foot ceilings everywhere, right? In other places, like 8-foot ceilings. I think 8-foot ceilings are kind of the limit. Okay? I think their building code says that 8-foot ceilings are the lowest ceilings that you can have. Okay? So we need to define what the height of our ceilings are before we go any further, right? How can I move all of the polygons that represent the top of my wall to a very specific place within the scene accurately? How can I do it? Just the top ones. I only want to mess with the top ones. The bottom ones, perfect.
We select them
Select them? Yep.
and go to the polygon mode.
Okay, I like it. Let's just select them real fast. Boop, boop, boop. Here we go. Okay, I can move them. But where am I moving them to? I want these to be precisely 10 feet tall. Okay, I like it. View dimensions. Yeah, that's not giving me what I want, right? Because I can't move. It's only giving me the dimensions of the selected element, right? If I deselect it, then I'll get the height. Then I can see that they're 18 feet 8 inches tall. Yes, set position. Set position is magical. It's the most useful tool, in my opinion, inside of Moto, because it allows us to work with accuracy. I can very quickly select the polygons that I want to change, and then go to set position and say, hey, I want you to be 10 feet excuse me, 10 feet along the y-axis. Boom, moves them there. Moves them there. Now I know beyond any reasonable doubt that the height of my walls are precisely at 10 feet. Precisely at 10 feet. I love it. Love it, love it. Fantastic. Questions?
Your screen says inches, mine says
Millimeters. Okay, so if you want to work in the world of inches, okay, it's really easy to change the unit of measurement within inside of Moto. It requires us to go into the Moto preferences, and you can find those by going to the top of the screen where you see the black pull-down menu that says Moto, and there it is, Preferences. You're going to get this pop-over, and it's a pretty crazy long list of preferences. There's a lot of options that you can control in here, but if you go down to the bottom of that list, you'll find this Input section, and there it is, Units. Units. And if you select that option, the top of our panel over here, there we go, Unit System, you're in metric or SI. I'm in English. I'm in English. Okay, and you can see that the default unit is feet. If you think in inches, if you want everything to be in inches, you can change that there by going into default unit. And the inch cutoff scale is basically going to determine at what measurement it's going to stop displaying inches and start displaying feet. Okay, so at the unit inch cutoff scale, I can type in 36, and it'll show up as 36 inches. If I type in 37, what is the readout going to give me? 3 feet 1 inches. Okay, so you can change that. You can change that if you'd like. Pretty great, huh? Pretty great. All right, questions, questions, questions. Let's take a break. I've been yakking for over an hour. Let's take a small break. Come back, talk about Booleans. Okay, let's hit it. All right, so before we started our nice, lovely little break, we've been working with our house, and things are starting to look pretty good, right? But the one thing that's kind of strikingly absent in my house are, of course, windows and doors, right? We need to have some holes in our walls to reproduce the illusion of windows, okay? So let's talk strategy. How can I get a window? How can I get an opening in the walls to get a window, or maybe an opening for the front door? How can we get that in that information? Yeah, Alan.
You create a separate shape or mesh in the shape of the window or and then use it to carve out the whole wall.
I love it. And what he's talking about is a Boolean operation. We're going to talk about Booleans here in a minute, but I want to just kind of remind people of why we're choosing to use Booleans in this particular instance, okay? A lot of folks, when they start working with the modeling tools in Moto, they immediately go to the tried and true favorites, the slicing tools. Maybe I can slice some walls or some openings in my walls. Because what we need to have in our mesh are a whole series of edge segments that define where these windows and doors are going to take place. Okay? I want to zip over to the front viewport here, and let's just explore how maybe the loop slice tool can give us the result that we're after. So I'll just fire off loop slice. Alt-C, there we go, and right now I'm using a count of 2 in a mode of uniform, and what we can see here, the loop slice tool, or mode of free, excuse me, the loop slice tool is really going to allow us to, place the top and bottom edges to establish our windows, right? So we can establish the height of our windows. What loop slice isn't going to do is establish the width of our windows very well. Because last time I checked, all of our windows should probably be the same size, right? If we don't have a specific measurement in there, the windows are going to be varied. Some windows are going to be pretty wide, some windows are going to be pretty short. I want precision. I want all of my windows, believe it or not, to be the exact same width and height, okay? So loop slice isn't going to give us the accuracy that we need on the width side, okay? In addition, loop slice is only really going to slice the outside of our walls. So we kind of have to double up our work. We have to do a whole series of slicing on these guys, okay? Check it out. It doesn't do the inside, okay? The only way for us to do the outside and the inside at the exact same time would be to use the slice command. And that is incredibly custom. We don't get a whole lot of accuracy there, so that one's out. Thus enter the role of Booleans. Booleans are going to give us the accuracy that we need. It's going to give us the uniformity and consistency along the geometry that we're after. But it requires us to think a little bit differently. The Boolean operators are going to allow us to take existing pieces of geometry and use them to kind of influence other pieces of geometry. We're basically going to make a whole series of holes and openings along the walls of our building from the shape of existing polygons within our scene. Okay? As Alan pointed out, we're going to carve out some holes in our wall based on the size and dimensions of some other pieces of geometry. So this is a geometry to geometry kind of operation. We're using geometry to slice other geometry. The product of this is still going to be a slice. There's still going to be, and we're going to get some openings here. Okay? So let me show you how to set up this entire process. The first thing that we're going to do is that we're going to get a little organized. I'm going to go back in time, get rid of those slices. There we go. The first thing that we need to do is get a little organized, okay? Specifically, I'm going to name my mesh house, not hose, house. There we go. All right. It's important that while we're working with these Booleans that we separate all these elements away from each other, because I don't want to run the risk of accidentally completely destroying my house mesh item. So it's important that I put all of the elements that are going to be carving the holes in my walls, the cutters, on their own mesh item. Okay? That way I can control them independently from the rest of my scene. So I'm going to create a new mesh item, and I'm going to name this mesh item cutters. That way I know that the only thing on this mesh item are going to be pieces of geometry whose sole function is to cut another piece of geometry. All right. Let's go ahead and start crafting the openings of our windows. Okay, let's do it. All right, so I'm just going to use the cube tool here, and I'm going to flush out how large I want my window to be. Somewhere, I don't know, something like that. Brilliant. All right. So that's going to be the width and height of my window. However, in order for Booleans to work correctly, I need to have the geometry cross through the wall. So if we're looking at our scene from the top, this is what we should get. It needs to cross, okay? In essence, what we're kind of creating here are like cookie cutters, okay? We're creating cookie cutters. The geometry that we've crafted is the cookie cutter. It's going to create an opening, a hole in our cookie, which is the house. So they need to cross through each other so the slice operation will work correctly. Now, it doesn't matter where they cross through each other. It doesn't matter if it's, over here. Oops, excuse me. Let me double click. Doesn't matter if it's over there or in the middle. They just need to cross. This is no good, okay? It has to cross through entirely like that. I always just try to get it into the center just so it's a little bit easier for my brain to manage what's going on. All right. Okay. So there we go. There's our little opening, or there's our little window. Awesome. Let's go ahead and start the Boolean operation. So we have one mesh item that contains the piece of geometry that's going to serve as the cookie cutter. And then we have our other mesh item, the house mesh item, that contains the cookie. In order for this to happen, we need to follow a very, very, very specific order of operations here. The cookie, in our case the house, needs to be the mesh item that's active and selected within our scene. So if I go over to my mesh item and select my house mesh item, it's now, in the world of Moto, the foreground mesh. Okay? It is the active mesh item. Everything that's unselected is the background mesh items. So the unselected ones are the background mesh items. We visually get to see the difference between the two because we can see that the background mesh items are going to get that black wireframe. Okay? All right. With this selection system in place, I'm free to go off and to fire off the Boolean operators. You can find them in a couple different places. The easiest place to go is the geometry pull-down menu, Boolean, and then we have three different commands, three different tools. We have axis drill, solid drill, and Boolean. Each one of these is going to give you a different result. I want to focus our attention today on solid drill. It's not that I don't like the other two. They give us some very nice effects. But solid drill is going to give us options. Okay, it's going to give us the most flexibility in steps 3, 4, 5, 6, 7, 8, 9, 10 afterwards. Okay, remember we got to be like chess players, thinking 8 or 9 steps ahead. Solid drill, it's going to give us options. Okay, it's going to give us the ability to choose what we want to do next. So if we select the tool, we're going to get a little popover. There it is. And this is where it gets a little bit confusing, so I apologize. Because we've selected the tool, now we have to select some options that are going to tell the tool how to behave inside the scene. The operation is going to be the series of rules that's ultimately going to determine what happens to my cookie cutter. Okay? Right now the operations default is set to core. I'm going to change it to slice. Okay, driver mesh is set to background. Everything that's in the background. Okay, and then let me zoom out a little bit here so you guys can see what's happening. Okay, and I'll hit OK. Boom. So what happened to my mesh down over here? We cut it. If I turn off the visibility of my cutter mesh item, check it out. It precisely sliced my cookie cutter, my house, the walls of my house, to match the pattern of that cube. Okay. Welcome to Booleans. We're having one piece of geometry influence another piece of geometry.
So we can make like windows around the house before we cut them.
You got it. You got it. And the great thing about this is, check it out. Unlike loop slice, it did the outside and the inside at the exact same time. Okay? At the exact same time. So we have the opening. We've defined our opening with polygons. So now we need to kind of make a window, right? We need to make a window, and this is why working with the solid drill is such a better tool than the other ones, because we get to choose what we do next. Okay. Ultimately, if you just want to create an opening, check it out. I can select that polygon and select its counterpart on the inside, and then run the bridge command. I'll single left click in the scene, boom. Now we have a window. Drop the tool, and there it is. It's a humongous window, but it's a window. It's a window nonetheless, okay? However, Moto is awesome, okay? It can do some really neat things. One of the great things about the Moto toolset is that there are other features that we can add on to these tools. Remember those profiles that we were working with the bevel tool? Remember the candle holder that you made when we were using those profiles? Well, we can use those profiles again here with the bridge command. Check it out. It's really, really neat. I want to hit undo a couple times. Here we go. I still have that outside window selected and the inside window selected. So if I fire off bridge, check it out. If you look carefully, any tool that has this profile thing in it can access that profile library. So, for example, if I grab, I don't know, bead, let's just see what we get here. And left click, not working, okay? The reason it didn't work is because we had to adjust one additional parameter, and it's the segments, okay? The segments. In order for the computer to generate that profile, that curve, we needed to give it more geometry. So by increasing the segments, we're going to get what we want. Okay? Pretty neat, huh? And we're in the driver's seat, so maybe we only want a couple segments in here. There it is. And now we've created a really cool opening for our window. And this is still a live tool, so I can change the profile and keep going. Yeah, that's pretty great. That actually kind of looks like a window now. Okay? Looks pretty neat. These profiles are awesome. They allow us to very quickly add high-resolution detail without a lot of fuss and fuss. Here's kind of a cool little modifier. I've been increasing and decreasing the number of segments when using the bridge tool. If you were to left-click and drag while the bridge tool is still active inside of your OpenGL viewport, watch this value right there. I'm just left-clicking and dragging. So that's the way to interactively change. Yeah.
However, what if we want to actually have windows, feel the window? What do we need this extra polygon?
Yeah, you're going to need some extra polygons in there. So Melanie brings up a really great question. What about the actual windows? Because really kind of what we're making here is the cases for the windows. What about the glass and the buttons and the rails and all that jazz that we actually see on the windows themselves? Some of those things you'll have to craft independently, but let me show you a really great power user trick. I was going to talk about this at the end of class, but since we're there, let's talk about it now. We need to have some geometry to establish the window. So if you look very carefully, in my little window opening here, I have a row of polygons. I'm going to run loop slice with a count of 1 and a mode of uniform. And my profiles are still on. And FYI, profiles work with loop slice 2, excuse me. So let me turn off my profiles. And what I'm trying to gain here is just a single row of edges that goes around the center of my opening. Here we go. With that edge loop selected, I can just hit the P key to fill that selection with the polygon. And now I have a window. Okay, now I have a window. Ultimately, at the end of the day, that polygon is going to get its own custom material, right? Glass material, like we've been working with the past couple of weeks. Yeah, really good. Really good. Pretty cool, huh? Pretty cool. We have some more work that we have to do in front of us, though, because we need a lot of these windows, and I want all of these windows to be exactly the same. So I'm going to hit undo a number of times and get us back to the point. There we go, before the Boolean. So I want to show you guys some additional options in here that makes Booleans a little bit more powerful. Okay? Why we like to use Booleans is that it gives us uniformity. We can have all of the windows and all the doors be the exact same shape. We can guarantee it with some certain level of precision here that they're identical to each other. How? I want to have a window, 2 windows in the front of my house. Okay? So I want to have, I want to make this window just a tad bit smaller. Okay. I want to have a window here. And I want to have a window here. And then I want to have, maybe 3 or 4 windows go down this wall. And maybe 2 more windows back here. How can I get all those windows to look identical to each other? Eli? Copy and paste. We need to clone them, right? We need to duplicate these windows over and over and over again. Let me show you a couple strategies that will help duplicating and positioning your windows a little bit easier, okay? Over the last couple of weeks, we've been focusing a lot on the duplication tools. We've talked about arrays and clones and radial arrays. Shoot, there's even the good old copy and paste, and that's what I'm going to initially do to start this guy off. I'm going to select my front window here, okay? Edit, copy, edit, paste, and now I can just move that clone wherever I want it to go. Let's rotate it 90 degrees around the y-axis. My pen is wigging out here. There we go. And if we look at our scene from the top, we can position this window where we need it to be, just somewhere right around in there. FYI, if you have your Booleans, the cutter mesh crossing into each other, that's okay. No biggie. All right. Let's see if I can figure out where I'm going to position this bad boy. There we go. Looking good. All right. Now, I want to have 4 windows that are going to cruise along that wall in my house. What tool is going to allow me to generate all 4 of these windows? Thomas? Clone tool. The clone tool is our jam right now. This is going to be the tool that's going to allow us to create duplicates in a straight line. Okay? Clone tool. Which tool allows us to make duplicates in a circle? Radial array. Radial array. Okay? We want a straight line, so we're going to be doing the clone tool. Let me zip over to my duplication tab. Double click my little guy here. And I'm going to clone this bad boy. I'm going to clone it. Single left click in the viewport and start to establish the distance that I want between, the distance that I want between all my windows. Now I want to show you a really cool feature inside the clone tool that I don't think we talked about a couple weeks ago. With the default features, this is exactly the way the clone tool is going to work. I need to add another clone in there, right? So the number of clones needs to go from 2 to 3. Once I increase this value to 3, boom, I get another one popping out there at the end. Okay? Let me show you an alternative to this that's kind of cool. I've put the number of clones back down there to 1. And check this out. I'm going to turn on between. Between basically allows you to define the beginning and the end. So the first one in your row and ultimately what would be the last clone in your row. Once we start increasing the number of clones to a value of more than 1 with this between option active, watch what happens. It's going to split the difference. They're going to try to evenly distribute all of the clones between the first one and the last one. So another option to make it a little bit more powerful. I like working with between. It just gives us some precision. It gives us some precision. Okay, I don't want 4. I want 3. And they'll all update. As if the tool's still live, they'll all update. Let's figure out where I want those to go. Okay, so if you look carefully, all the windows are evenly distributed to each other, right? The distances between the clones are identical, but my OCD brain is going crazy right now because these windows are not centered on the wall that they're going to be placed on, right? They're evenly distributed along each other between these guys, right? But there, I mean, if you look closely, you know, there's a very large gap here, very large gap here, very small gap there. I want all 4 of those windows to be centered in that wall. Ugh. How am I going to do that? Let's talk strategy here. What can we do to get those 4 windows centered along that wall? Huh? Flip the table, walk away, and say, I'm done. There's no way this is possible, right? So ultimately, what do we need to do? Don't think about tools. What do we have to do here? We just got to move them, right? We just have to move them. So now we're kind of in the ballpark of the tools that are available. So the most simple tool that we can use to move something is the move tool, right? Okay. So there's nothing that says we can't go in and do this. Grab all the windows. Maybe look at it from the top. And you can see that much bigger gap over here. And now we're doing my least favorite thing, and we're eyeballing it. No likey the eyeballing, okay? I really don't like eyeballing it. I want some precision here. I want to ensure that the distance is even, okay? All right, let me show you a really cool trick. For the past couple of weeks, we've been talking about the role of the work plane within our scene. You can see my work plane at the moment. This light gray grid that's always available to us, okay? It's always on. We can never turn it off. What does the work plane do? From what you've experienced thus far in Moto, what does the work plane do? Yeah, it gives us accuracy. It's a snapping guy. Quinn?
It's kind of just like the, I don't know, canvas which you make things on.
I like it. The canvas that you make things on, and very much so, right? We've been using the work plane to determine where our shapes are created from, right? If we want, the blueprint of our building to be generated along the XZ plane, well, we rotate our perspective viewport to the work plane snaps to that area, and then we can draw our object from there, right? It allows us to create objects where we want them to be created. But the work plane is so much more than that. The work plane is probably, for me, it is the reason to buy Moto. I rely so much on the work plane these days that it would be very difficult for me to model without it, because it can change its location. The work plane can move, which makes it an invaluable resource for us. We can use the work plane as an alignment guide, okay? Check this action out. We can move the work plane based on a selection. The work plane, in essence, is nothing more than a grid. All grids have a center point, okay? All grids have a dead center. Now, you don't see the center point of the work plane, but it's there. I want to align my work plane to that shape there, okay? That's where I'm going here, okay? I've selected a polygon, and then check it out. At the top of the screen, we have this really, really, really groovy work plane menu. Inside of that work plane menu, we have a number of tools, but the second one is align work plane to selection. Now, when we turn this on, the computer is going to automatically go in, analyze whatever it is that we have selected, and try to move the work plane to the center of that selection. Check it out. This is cool. It's really cool, actually. I love it. Love it, love it. Check it out. We'll align the work plane to the selection. Bam. You can see that my light gray grid has moved. As I orbit around my scene, it's no longer updating and responding to my orbit. It's permanently glued to that new location. Now, I mentioned a moment ago that our work plane is a grid, and all grids have a center point. With the default visibility options, we can't see the center of our work plane. If we return to that work plane menu that we were just in, at the bottom of that list, there's a really new tool in here. It's called Draw Axes. And that's basically going to give us an indicator as to the current location of the center point of our work plane. And if you look very carefully, where is the center of that work plane? Center of the polygon that we had selected. Okay? In essence, what we have done is that we have changed the origin of the work plane to the center of the polygon. If I wanted to move my windows, if I wanted to center all of my windows to the center of that polygon, which just happens to be at the center of the work plane, what tool? Center selected. Let me, I'm pulling back the veil of Moto here. We're peeking underneath the hood of the Moto modeling tool set. When you choose center selected, you're not actually moving things to the origin of our three-dimensional scene. You're actually moving things to the center of the work plane, whose default location is where? The origin of the scene. Okay? So with that said, if I choose center selected right now, if I selected all my windows and chose center selected, what's going to happen? Where are those objects going to go? Center of the work plane. Okay? Check this action out. It's really cool. Now, also, please note that the orientation of our work plane is different from the orientation of our global axes. Okay? We know from experience that all of this stuff up in here represents the positive y-axis. The indicators, the axes have kind of changed a little bit. So we have to be careful. Don't do center all Analyze the axes that are being drawn in the center of the work plane. Which direction do I want to move my windows? Yeah, along the Z, the local Z, the blue one, okay? So that's the option that I'm going to choose when I fire off center selected. So I'll do basics, center selected along the Z axis, boom. My windows moved. And now they're precisely centered in that polygon. Love it. Love it. This is the accuracy that you kind of have to go through when you're doing this type of work, okay? Believe it or not, architects like it when things are centered. You know, it kind of seems obvious, but this is kind of an important point, you know? We need to make sure that the distances between the left side of the windows, this over here, this distance is the same as this distance here. The work plane gives us that accuracy, okay? Now, whenever we're working with the work plane and we align it to a custom polygon, we need to put it back to its original position when we're done. Believe it or not, almost every single system inside of Moto is working in conjunction with the orientation of the work plane. So right now, if I was to view my scene from an orthographic perspective, it's going to look all funky because the work plane has been changed from its original position. So if I was to look at my scene from the front, is that the front of my house? Kind of, but it's all rotated, oddly. If I look at my scene from the top, that's definitely not the top of my house, okay? The reason our orthographic viewports are showing our scene incorrectly is because we've orientated our work plane to a custom angle, okay? Once you're done working with the a new version of Java is available. Skip this version. Once you're done working with the work plane, you got to reset it. Reset the work plane back to its original location. And I'm going to turn off draw axes. And now all of our orthographic viewports will go back to behaving as they should. There's the front. There's the top. Balance and order has been restored to the universe once again. Okay? We love working with the work planes. Okay? They give us a tremendous amount of control and power over the placement and the creation of objects within our scene. Love it. Love it, love it, love it. Okay, let's keep cruising. A couple other ideas in here. Now, I've gone through great pains to place all of these guys where I want them to be. How can I duplicate them and get a copy of all of those selected polygons on the other side of the x-axis? What tool am I going to use? Mirror. Okay, so don't forget about mirror. I'm all about doing half of the work. Okay, I really am. If I can mirror geometry, I'm going to mirror it. Okay, that way I precisely know beyond any reasonable doubt that the left side of the house is identical to the right side of the house. Just double check to make sure everything's selected. Yep, good to go. And go to duplicate, mirror. I want to place my action center for this tool at the origin of my scene, then left click. Boom. All right. Rock and roll. All right, so windows, done. Before we do the Boolean operation, let's do the door too. So we'll do them all in one mighty fail swoop. Okay, let's make the front door. Look at the front. Now for the door, what I like to do is extend the length, the height of my door way down past the bottom of my building. Okay. For the door, we need to have it penetrate through a couple different areas. Of course, we got to have it penetrate through the walls like here, but we also want it to go, below as well. Okay. I need to get this into the center, so let me center this. Do center selected all. Oops, didn't double click on it. Sorry, my fault. Center selected all. There it is. All right. Now, when I center selected all, something kind of happened. It lowered down. It did what it was supposed to do. It centered that entire cube around the origin of the scene, but it kind of messed up my alignment a little bit. I want to have the top of the door being the exact same height as the top of my windows. How am I going to do that? Just move it. Who do you think I am? Just move it. No, we're not going to just move it, right? Because that's eyeballing it. I want precision. I want it to be exactly in the same height as top of my windows, although I like your style. Yeah, Thomas.
I was thinking, couldn't you duplicate? No, never mind.
Okay. Snap it. Snap it. I like, if we snap it, however, you know, I don't know if the top of the windows are on a grid square. So that's out. And I can't move it left or right. I just want to move it up.
Use the work plane thing again.
Yep.
Use the work plane, set it to the top polygons of the window.
And then center it that way.
Yes.
Another good way. I like it. I like it. What Nathan's talking about is using that work plane once more. Okay. This is absolutely a legit way of doing it. Maybe I grab those two polygons. I align my work plane to there. Okay. Now the origin of my work plane is centered along this height. And then if I just center selected that polygon along the Y, boom, they're all in the same height. That works. That works. It's a great way of working. Let me hit undo a couple steps and reset my work plane. I want to show you one other way. And this is something new. We're going to use set position, okay? But what value am I going to enter in? I don't know the height of those windows, and I don't want to guess. I need to go figure out where those polygons live, what the coordinate, the height of all of those values are. Check it out. I need to figure out the height of that vertice right there, which is connected to that polygon, okay? So I need to figure out the height of that window. One of the cool things about working in Moto is this lists tab. So we got properties, that's usually where we kind of hang out for the most part, but if we keep cruising down this row, we have lists. And down at the bottom of lists, we have info and statistics. Info is a really great panel because it's going to give us very precise information on whatever it is that we have selected within the scene. I have a single vertex, and actually it's vertex number 5. This is a randomly assigned number, vertex number 5, and it's given us its XYZ coordinate there. Aha! So now we know where it lives. How are we going to use this information?
We'll give the same value to the door, the same value in the window.
Yes, absolutely. But how can I get it?
The y, we'll take the y value
The Y value?
and give it to the door.
Okay. The set position, that's what we wanted to do. I'm not going to write it down, though. Copy. Yeah, a lot of folks don't realize that you can click in these numbers here, and you can copy them. Okay? You can copy that value, Command-C, because there's no way I'm remembering 9 feet, 0.75 inches. Sometimes they get really weird numbers, so I'm just going to copy it because I'm lazy. And if I select the top of what it's going to be, my door, I can go vertex, set position. Now, as Yusra was saying, just paste it in along the Y. Boom. Same height. Same height. Okay? This info tab, fantastic. Fantastic. It gives us specific information about coordinates. It's giving us the exact XYZ location of any selected component within our scene. And this blows my mind. I've been doing a lot of 3D modeling over my career, okay? And I've used basically all the big apps, Cinema 4D, Maya, Max, Lightwave. This is actually kind of unique. This is not something that you see in a lot of other applications. It seems kind of obvious, but Moto is tracking all this and giving us this information, and I love it because finally I have a tool that it gives me the accuracy that I need with my crazy OCD brain. Okay, like I mentioned before, I'm both the right person and the wrong person to be a 3D modeler because I kind of go crazy with the accuracy. I like things straight. I like things aligned. It's got to be like perfect. Okay, now that we got it, let's keep moving on. Now that we got everything perfect, let's get our door where it needs to be. It's got to cross through my walls, so I'm just going to move it. Excellent. And now I can start the Boolean. I'm ready to go. I won't do the back door. I'll just do the front door. Okay. So help me out. Which element within my item list has to be the selected element? The house, right? That's the cookie. The cookie cutter is going to be the cutter's mesh. And that's going to be unselected, so it's in the background, right? Whatever is selected is in the foreground. Whatever is unselected is in the background. So let me select my house. We'll do geometry, Boolean, solid drill, and we can do slice. Slice, you've already seen the result. Let's check out some of the other options inside this tool. Here's core. What did core do? The opposite, right? It gave us just where the cookie and the cookie cutter intersected with each other. The rest of the walls, gone, right? Been deleted. Bad. So core is going to give you the intersection between the cookie and the cookie cutter. We do it one more time. Boolean solid drill. Tunnel. Hey. All right. Rock and roll. Okay. I like this a lot. However, tunnel doesn't give us the option to go and do that fancy bridge command that we were working with before. So, maybe not in this particular situation, but you can see the result that we get. Stencil and slice, very, very, very similar in behavior. Okay. So we have stencil and slice. They're going to give us almost the exact same result. I like slice. There we go. And you can see the result that we get. Now we're free to go in and start punching holes in walls and start making our windows. Okay. You have to do them individually, unfortunately. Okay. So let's go back to mesh edit, or excuse me, duplicate, bridge. Let's turn my profiles back on. And it doesn't matter which profile you use in this particular situation. One that's fun. That will do. And then you can just keep going. Now, one of the cool things about working inside of Moto is that it's going to remember all the options of the tool from the previous usage. Well, that's giving us a lovely render error. We got to fix that. Okay, we got to fix some stuff. See how we're getting a render error here? See how the OpenGL viewport's giving us these really weird, kind of funky shading errors? Not good, okay? This is the OpenGL engine telling us that it doesn't know how to draw this polygon. It doesn't know how to draw this shape. And whenever you see render errors like that, you need to stop and really do some detective work on your mesh, okay? For me, what's going on is that we're trying to use that custom profile when we're bridging the two windows to make the opening. And it's not, and the computer's having a hard time trying to figure out if that surface is flat. It's starting to think that maybe it needs to have some additional geometry and it's torqued a little bit. So here's what we need to do first, and this is kind of good practice. In essence, what we've created at the conclusion of our Boolean operation is a whole series of N-gons, right? So if we go back to like week 2 in here, we started talking about the basic surface types in all 3D apps, right? We have a vertice, we have an edge, and then what's our first surface type? Connect 3 vertices together, what do you get? First, it's before we get to a polygon, we have what? Triangle. 3 vertices triangle, okay? Triangle. It's so easy, it's hard, okay? It's a triangle, okay? So we have a 3-sided surface is a triangle. A 4-sided surface is what? Square or a polygon, okay? But what if you have a surface that has more than 4 surfaces or more than 4 sides? That's called an N-gon, and we know likey the N-gons, okay? Moto supports them, but it's kind of a bad form to include them in your model, okay? We want to try to get everything into the standard uniform surface types as much as we can. We want them to be our model as much in quad polygons as we possibly can. If we look at the walls of our home right now, okay, check it out. That is a gigantic N-gon. If we start counting the vertices on that shape, we got 1, we have 2, we have 3, we have 4, then we keep cruising around, then we got 5, 6, 7, 8, 9, 10, 11, 12, 13, blah, blah, we have a whole bunch, okay? This is bad. We need to slice our mesh and get it into quad polygons as quickly and as easily as we can. This is good modeling, okay? It's important that we generate geometry that is universal. Geometry that I can send over into another app for animation, for rendering, for dynamic effects. It's important that all of our geometry be as open and as universal as we can. If we create geometry, the model that only works inside of Moto, we have issues. We have big issues, okay? Question? No, okay. So what are we to do? What to do? We need to slice up our geometry. That's what we need to do. But how are we going to do it? We got a lot of slicing in front of us. A lot of slicing. and then do what with them? Delete them? Kinda. Let me show you a better option. We need to slice up our mesh. Now, there's a number of ways that you can do this, but let me show you Pat's really fast way of slicing up our mesh. And we need to control what we slice. Ideally, what we don't want to try to do is we don't want to try to do edge slice, right? Edge slice seems like the rock star that we want, right? Because it allows us to very quickly slice our mesh like this, go around, connect it up like that. Awesome, right? Then we do the same thing for this guy. But I got like 20 windows on this bad boy. It's a lot of work. A lot of work, okay? So edge slices out, and it's never going to be accurate. The edges aren't going to be perfectly straight, and you know me and my perfectly straight lines. I got to have perfectly straight lines, okay? So we're gonna combine a couple of the things that we've been talking about today into one modeling operation. We're going to use the slice tool, right? Because slice is awesome. The laser that's going to cut through our entire house. I know that the windows on the left side of my house are in the exact same location on the right side of my house. So with that said, I can do both sides at the exact same time. Not have to worry about it. We're going to use the laser that is the slice to cut through my mesh and quickly get the results that we want. We're also going to pair it with the snapping engine to make this whole process go a lot faster. Because I don't want to think about where this slice tool is going to be placed. I want it to automatically snap to the existing vertices. Kind of what I was just doing with the edge slice command. Let me show you how this is going to work. It's pretty fun. It's pretty cool. I like to focus the entire slicing engine on just the polygons that I want to work with, just by selecting them. I don't want these interior polygons to be selected, and I certainly don't want to accidentally slice all of this stuff or all of this stuff down over here. So I want to make a selection. There we go. Boom. Brilliant. Okay. And now I'm going to look at my scene from one of the orthographic viewports. And I think in this particular case, I'm looking at my scene from the right. So I've made my selection. I want to activate my snapping engine and then go into the snapping options and activate, how about we do a little vertex snapping? Boom. I love it. There we go. Cool. Now, watch it. Check it out. Let's go into Mesh Edit, Slice. If I hover over a vertex, you can see that it automatically snapped to that vertex, right? And I'm also getting a straight edge snap as well. Bam. Love it, because now I'm slicing through the entire house, and it's precisely snapping its action handles where it needs it to be. Something like that. And I've dragged the bottom one down below. This slice tool can also be repeated by holding down the Shift key and then left-clicking and dragging. And I can drag down, hold down the Shift key, grab the next one, drag up, but I want it to slice the entire row, so I'll drag down and rinse and repeat. Hold down Shift, click up, click down, hold down Shift. And within a couple mouse clicks here, I'm getting the result that I want. Okay, we also want to slice it going horizontally. So we'll do it one more time. This one's going to go boom, 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 boom. You can see it snapping and updating. One more time. For the top, we're on our way. Within a couple mouse clicks, look at all the work that I just did in a couple mouse clicks. Okay, we have the structure that we need for all of these windows. I can go ahead and bridge them together now. FYI, this little diagonal guy, yeah, you can delete that now. Okay, no longer needed. Yeah. Go ahead.
What about the side of the door? The vent on both sides of that too?
Yeah, so we have to do the fronts too. We have to do the front and the back.
Couldn't you have just selected them because they're both the same height anyway?
Yeah, if when I did the horizontal one, I could have selected both of them too. Yeah, for sure. For sure. However, you know, if you look carefully at what I have here, I can just use edge slice to do that. Cool. Same thing over here. Hold down the Shift key, refire edge slice. Hold Shift key. There we go. Let's get the front kind of dialed. We're going to do the exact same thing on the front. Do the back as well. Excellent. Brilliant. Turn on my snapping engine. Activate the slice command. Now I'm slicing. One of the things that I've learned when using the slice command is you want to go all the way through the mesh. Notice that the ends of my slice handles aren't on the inside of the geometry. They're on the outside of the geometry. That ensures that you're slicing through the entirety of the polygons. There's not going to be a floating vert on the inside somewhere. Something I picked up from my experience. So one more time to the top guys. Those look like they're already pretty much done. And then we'll do the verticals. And huzzah, there it is. Now my house is ready to rock and roll. Oops, looks like I forgot to do the door. There we go. And now we can go in, here's the door. Let's just bridge that real fast. And now it's just not more than doing some bridging. So here's bridge. I think I have a profile turned on. For the door, I'm not going to have a profile. I'll just single left click. And I don't need those two polygons down there, so I'll delete them. Yeah. I wonder why those verts are still there. It's from the bridge. That's interesting. But we can always go get those later. All right. And then here's all our windows. I won't do the profiles because I think I may be able to do all these at the same time. If I'm just doing a simple bridge without any profile, nope. Take that back, liar. Looks like it's each window at a time. Yeah, when you're doing bridge, it's actually trying to, it's analyzing all the selected edges, and it's trying to connect each edge sequentially. So when it messed up like that, it was trying to connect all the edges in the window into one gigantic polygon. I won't do the entire house, but just so you get an idea. We're getting there. We're getting there. All right. So our house is looking pretty amazing, but it's missing something, isn't it? A roof. And a floor. And a floor. A floor is easy. We can do a floor. That's just a simple ground plane, okay? But a roof, kind of important. Need to have a roof on our house, right? Especially during the summertime here in Sacramento. Otherwise, it's going to be really, really hot inside of our house, right? I like to have it nice and cool inside my house, okay? So we need to make a roof. Let me show you a couple ideas on how we can make roofs. Roofs are probably the most the easiest created if you work in 2 dimensions first. We're going to make just kind of a single, a center ridgeline roof, okay? So we're not going to do like one of those roofs that look like a pyramid, although I can show you how to do that real fast. It's just going to have a center ridgeline, kind of like a barn, okay? Now, if you think about it, it's important that we construct our roof in a fashion. Let me create a new mesh item so I don't accidentally screw anything up. I would hate to get this far to have my model completely ruined by a rogue roof, okay? We need to have our roof created in a fashion that allows us to control the pitch of our roof easily, okay? That's the idea. We don't want to rotate planes. I just want to be able to do this, whoop, kind of like a hinge, okay? That's the idea. That's the goal. Let me show you how to do that quickly, okay? I'm going to start with a cube, 2-dimensional cube. I'm going to draw out my cube, make it to the thickness that I want, and then I'm going to center it. Center along the X, okay? And now I need to create a center line. How do I create a center line for this 2-dimensional plane? Slice, absolutely, slice. We've been working with slice. I don't need to turn on the snapping system. I'm just going to fire off slice, and if I hold down the control key before I click, it'll slice a straight line. Now I need to make sure that that's perfectly in the center of my scene, so I'll do a little vertex set position. a value of 0 along the x-axis, and boom, there it is. Now I know that this side is identical to that side, okay? And the center line is precisely at the center of the origin, okay? Let's get this guy into position here. Let's turn off my action origin center. And get this thing where I want it to be. Maybe somewhere right around there. Excellent. Okay. And now check out this action. If I just grab that edge and move it up, I can establish the pitch of my roof. Yeah, pretty cool. That's pretty good. Let's get this positioned where I want it to go. Maybe somewhere kind of like that. There we go. Love it. Okay. Now, when you're designing your roof, you need to be very aware of the overhang, of the eaves, right? The roof is extending much, if you look carefully over here, the roof is extending much further past the edge of this exterior wall than it needs to be. You're not going to see a roof like that. You're not going to see a roof like that at all, or an eave like that. So we need to get this edge, that one, closer over here. The eaves of our house are kind of like, this long. They're not too big, right? They're not like that, okay? So we need to get the edge of our roof closer to the exterior of our walls. How am I going to do that? Could? Okay. I like the way you're thinking. We're over-engineering it. That would work, though. That would work. Like on the martini glass, right? Basically, we need to move that edge, okay? If I just fire off the move tool, look what happens when I just move it along the x-axis. The pitch of my roof changes. Bad. I don't want it to change, okay? I don't want it to change. I want the computer to analyze the slope, the pitch, if you will, of my roof, and move that edge so that it doesn't screw up that pitch. We have a couple options in here. Let me show you some new things, okay? During our martini glass, we did the exact same thing with these little struts, those little support things that came out from underneath the umbrella, right? Do you remember that? Did the radial array, we moved them to be the correct distance from the edge of the umbrella. Well, we're in essence kind of doing the exact same thing. However, a challenge is presented. If I change my action center to selection, the computer is going to go through and currently analyze the slope of that selected edge. How would you describe that edge? Its position, its orientation. Yeah, it's perfectly straight up and down, right? It's perfectly vertical, right? So if we were to fire off the move tool with the selection action center, who we know is going to analyze the slope, no good, right? Because if you look carefully at the tool handle, it's still perfectly aligned to the global. It's still perfectly aligned to the global orientation of our y-axis. If I was to move it with the selection action center, I'm still going to mess up the pitch of my roof. Bad. Okay. I need to have one of these action handles kind of oriented along the local orientation of this polygon. In this particular situation, selection action center isn't giving us what we want. Let me show you another one that's equally as cool, okay? It's called the element action center, and it's pretty rad. I want to drop the tool, and I'm going to select my edge. I'm going to go to my action center and change my action centers to element. Now, on the surface, it doesn't look like anything's happened, but when we hit the move tool, so I got the move tool active. Check it out. There's my tool handle up in there. And if I left-click on any one of these components, it's automatically going to move that tool handle to the orientation of whatever it is that I clicked on. I clicked on that top edge, and it analyzed the slope of that element, and it placed the tool handle aligned to that element. And now, if I just move that handle, whoop, let me do that again, just so you guys can see what's going on here. Okay, I got my edge selected. I go up to my action center and change it to element. Now when I fire off the move tool, it's going to allow me to click on any element within the scene. and it will automatically position its tool handles so that it's oriented and matching that element's angle. Well, I want it to be like kind of along this slope. There it is. And now I can move the eaves of my house right about where I want them to be. Yeah, go ahead. Good question. Good question, yeah, because we've done the right side, we've got to do the left side. If we were to drop the tool, problem. Unless it's a modern design, perhaps, for our house, and then maybe it's intentional, but I want it to be symmetrical. What am I to do? Just mirror it. Just mirror it. The foundation for that operation is already set up, right? The ridge line is precisely where it needs to be in conjunction to the origin of our scene. So if I delete that side, grab that one, duplicate, mirror, change my action center to origin, left click, done. Okay? On my way. Those mirroring tools make it really, really easy to work on objects like this, because now if we're just aligning everything to the origin of the scene, we can make one side and have the other side automatically be generated when we mirror it. All right. So I've been working in 2 dimensions for the time being. Let's get this thing into 3 dimensions. I'm going to do an extrude. So I'll go polygon, mesh edit, extrude, click on the viewport, and just pull that shape back to where I want it to go. Somewhere perhaps right around in there. All right, looking good. Or here are we? What's wrong with my house? I got an opening. It's a gigantic hole at the top of my house. I got to fix that, right? Yeah, this is not cool. Not cool, especially for my heater or air conditioner, because it's going to be running all the time, okay? How do I fix this? A lot of duct tape. A lot of duct tape. Buy it in bulk. How are we going to fix this? Yeah?
We could use the house to Boolean some verts in the roof so that we could...
I love it. That's a great idea. That's a great idea. We can use a Boolean. We can use a Boolean. Now, I intentionally, you thought I was just doing this out of happenstance. I intentionally put my roof on another mesh item because I knew where I was going with this, okay? I'm going to use the roof as a Boolean for the house. Check this action out. Now, remember back to the original parameters of a Boolean, right? The geometry has to be crossing each other. It has to physically intersect each other so that the roof acts like a cookie cutter for the walls of our house. So what do I have to do to the walls? Nope. Yeah, we need to have them poke through the top of our roof in order for this operation to happen. Let me turn off the roof just for the time being so I can easily select all of these guys. Just grab the loop. There we go. Cue all. And now I'm just going to move them up. Like that. Brilliant. Don't worry about that cross edge. That's going to get deleted. So now that I have the geometry crossing each other, I can fire off the Boolean operator. Okay? The roof is precisely where I want it to go, but we're going to use its location and size to slice the walls of my house. So I can go geometry, Boolean, solid drill, and once again I'll use the slice operation. There it is. So now, what do I have to do to all of these guys? Just delete them. They're not going to be used, so we can just delete them. Grab all the ones on the top, and of course all the ones on the inside. I could do a loop selection, not a loop slice. Yeah. I'm using my little graphics tablet here, so. Something like that. Function delete. Oops, forgot one. Luckily, the computer will tell you pretty quickly. It'll be obvious when you messed up. And now, if I turn the roof back on, huzzah! There it is. Perfect. Pretty cool, huh? Pretty cool. Welcome to the lovely world of architectural modeling. Now, I mentioned a moment ago that I was going to show you guys real quickly how to make one of those quad cap roofs, the ones that look like a pyramid. Not all the roofs are going to look like this. And I want to warn you guys, okay? Roofs are the hardest thing to model in architectural visualization, okay? So when you're choosing to build your house this week, make it easy on yourself, okay? Don't try to make a, one of these crazy houses that's got like 8,000 different roof lines that are sloping at a whole bunch of weird angles. Make it easy, okay? Make it easy as you choose which model and which house style you're going to construct. If you want to have a roof that's got that quad pyramid cap to it, it's really easy to do that. I'm just going to start with a square, and it doesn't matter. It can be rectangular. A lot of homes are rectangular. Okay, so that's going to be the roof for my rectangular house. In order for us to get that kind of pyramid shape, we need to have a vertice right in the center. We need to have an edge going from the center vert to each one of those corners. Let me show you a really easy way for the computer to figure out and do this work for us. If I select that polygon, I can go over to my polygon tools. We can use our good old friend Spiky. Spiky. And if we left click, there it is. It automatically figures out the dead center of that square. And it's going to draw edges. It's going to basically kind of triangulate it. And it's going to produce a center point. Cool. And now, let me change my action center back to automatic. Just move it up. On our way. Ooh, ridge that comes down in triangles. Got it. I know exactly what you're talking about. Got it. So we'll do the same thing. Let me hit undo here. Let's see. Let's just do a loop slice. Count of 1, mode of uniform, because there's our guy. Let me turn off my grid so you guys can see what's going on. There we go. So there's our center line. That's going to be our ridge. Okay. And what? Let's see. We need to have an edge go that way and then that way, right? So, well, that's easy. We can do that by doing another loop slice. This time we're going to do a count of 2, mode of symmetry. That way we can figure out where along the ridge we want that triangle thing to happen. Okay? And then we just grab and move that edge. There we go. Kinda-ish. I still have some work in here that I need to do. Before I move it, actually probably what we should end up doing is use the edge slice tool to triangulate the corners. And then I'm going to delete that one there. Edge, remove, keep vertices. Okay, that way we have a quad polygon down there. Do the same thing for the back side. So this one's definitely a little bit more of a challenge than the others, but still not impossible. There we go. Now what happens when we move that up? There's the plane that I was after. Yeah. That's pretty close. That's really close, actually. Not bad. Yeah. Yeah, not bad at all. Yeah, and then just thicken it. And then thicken it. Same with the other one, with the standard pyramid, because it's still just a two-dimensional plane. So if you just run thicken, with this level of complexity, thicken may give you a weird, funky result. But it looks like I got lucky. Yeah, I got lucky. Ta-da! Roof. Yeah. It's amazing how much effort goes into making a roof. They're not exactly geometrically simple shapes. Big puzzles these things are. Big puzzles. Questions? All right, let's talk about our homework in our lab. We have a couple things that we need to accomplish this week for our work. Okay, if you go back over to renderography, our homework this week is a custom house. Okay, so you get to pick your house, do whatever home you want to make. Doesn't even have to be a home, it's a building. So if you wanted to do some sort of commercial structure, that's fine too. Okay, Make it easy on yourself. Make it easy on yourself, okay? Don't try to do like some crazy mansion that's got, a bazillion different roof lines and some really complex structures, okay? Keep it easy. Keep it simple. I think the projects that are the most successful in this time of year are the simple homes, okay? Also, I would recommend that you model something that you see every day. Model your own house, or model a house that you drive by or you walk by every single day, okay? That way, the accuracy of your model is going to go up because you're going to be able to see and understand how all of these different plane changes interact with each other on the surface of your home, okay? Try to be as accurate as you can. Look very closely at the proportions of your house, and specifically the details or how the details relate to one another. How big are the windows in comparison to the doors, in comparison to the wall and the roof? There are standard sizes for most windows and doors. So if this is a home that you see or a home that you live in or a building that you see all the time, be a really weird, geeky person and walk around and measure all the windows and doors, okay? I tell you what, if you want to get more dirty looks from anyone on campus, go grab a tape measure, start measuring windows and doors. People will stop and look at you. Okay? I know this from experience. Because I have done it. I've done it more times than I embarrassingly would like to. Let me show you an example. Oops. Grabbed the wrong one. Does anyone recognize this building? Yeah, this is the Cosmo building. Okay? And I've been working on the Cosmo building for a long, long time. Let me see. I think I have all the footprints kind of dialed in. This is actually, I opened up the wrong project file. This is actually the old one. Hold on a sec. This is actually the low-res one. Maybe it's been a while since I've actually opened this. Here we go. New Cosmo. Yeah. There we go. Yeah. So if you ever want to get really weird looks from people, yeah, go walk around with a tape measure. Especially at a public institution like Sacramento City College, people will stop and ask you what you're doing. It's awesome, let me tell you. And then once you explain it, they're like, "Oh, can I help?" So you're not a terrorist? You're gonna burn down the building? No, I'm not gonna, burn down the buildings. Yeah, I asked for all the because I want to make a 3D model of our campus, and I asked one of our top brass guys for the actual architectural blueprints. And he looked at me like I was absolutely crazy, And of course he said, "No, I'm not going to give you the blueprints for every single building on campus." And I told him, I was like, "What do you think I'm going to do?" And he's like, "I don't know what you're going to do, so I'm not going to give them to you." So I was like, "Fine." So I left, grabbed my tape measure, measured all the exterior of the building. You can't stop me. You can't stop me. I want to get my way any way I want it. That's right. Never trust a computer graphics artist. Never trust a computer graphics artist. I joke around with my wife all the time that the world should be happy that I'm not like an evil criminal type guy, because I could turn into like Bane from Dark Knight like really quickly. I could. Case in point, I totally could. Oh yeah. Yeah, there's a darkness inside of me that's growing. No, I'm joking. There's not a darkness. Yeah, right. Yeah, the voices are taking over. Case in point, this is probably like 5 or 6 years ago. I was doing a commercial for a nonprofit here in town, and this nonprofit, I've forgotten their names, but it was a car seat safety kind of nonprofit. And as part of a commercial, they needed a driver's license for like a little 4-year-old girl, right? And they said, "Pat, can you make us a fake ID?" And I said, "Yes, I can." Yes, I can. And I was kind of proud of it, but I remember the producer coming up to me and says, "Pat, this is scary good. You did this all in Photoshop?" And I was like, It looked identical. It looked identical to the California driver's license at the time. So never trust a graphic designer. Never trust a person that knows Photoshop, because reality is questionable. Reality is questionable.
Fake IDs.
No, I don't make fake IDs. I don't make fake IDs.
I
But
But it's not. So like in one thing, it's still both things are still multiple polygons.
yeah, okay. So he's actually running into a really unique and interesting viewport property that's in Moto 701. You actually have a background object and a foreground object, but it's displaying both of them at the exact same time. All right, check it out. Let me see. Yeah, okay. So here's kind of an example with the project file that I have open right now. You can see that I have the foreground object, which is the exterior of the cosmetology building, and then I have another object, which are the double doors that are right out front here. Okay. Right now, those double doors are in the background. However, if I hit the O key inside of my OpenGL viewport, I can change the visibility of our active items and our inactive items separately from each other. I think what's going on is that in your inactive meshes section, someone has probably turned on make inactive same as active. Is that what's happening? No. Okay. Let's see what's happening, because then it's going to shade everything equally. Let's see what's going on. That's kind of interesting. Are you sure? Okay. All right, what's on mesh 1 and what's on mesh 2?
This one is the second one.
Okay,
And
prove it.
So
Okay. All right, and then mesh 2 is that other piece. Interesting. Okay, go back to your OpenGL viewport properties. And this time, let's go into drawing and control.
should I just reset moto?
No, I want to kind of figure this out. Go into visibility for me. Okay, let's go into active mesh items and see what we can change in here. Shade style, advanced OpenGL. Enable independent drawing. Okay, now go to inactive meshes. Let's just turn on make active. Now click again. Sometimes it kicks it. Okay, I have no idea. You know what could have happened? They could have done it in the master preferences for Moto. Yep. And let's see. I gotta remember where in here that you can change it. Let's do OpenGL.
Include backdrops and
No, yeah. Boy, wow. This is a good one.
yeah.
This is a good one. Okay.
Should I just try to reset model and see what happens?
See what, yeah, try resetting it and reset the layouts first. Then just do restore. Yep. That's good. Now we're
there
back.
it goes. Okay.
Yep. All right. Okay, dokie. So let's go back to our homework we'll fix. Let's just talk about what you're expected to build over the next week, okay? Remember, this is a two-part assignment. Week 1, just geometry. Week 2, then we're going to focus on the textures and the materials to really make these shine, okay? So just focus on the geometry over the course of the next week. The geometry is due in the Dropbox by the beginning of next Thursday, or by the time we meet again on Thursday, okay? Couple things that I want you guys to build. Of course, you're going to be making the geometry for the house, or you're building whatever it is. But in addition, you're also going to be making a simple landscape for your building to kind of hang out in. I'll let you figure out how to build it, but you're going to need to build a landscape, okay? Your house, you have to give your house context. It's got to be a part of an environment, okay? In addition, you're also going to be building or including geometry for trees and bushes, okay? Now, you don't have to build these from scratch. You can if you'd like, but don't freak out about making trees and bushes, as Moto ships with a number of free trees and bushes, okay? If we go out to the Layout tab, trees and bushes, a lot of trees and bushes. Now, some of these are personals that I have gotten elsewhere, but if you go into the Meshes section in the Layout tab, there's a folder. Let's just take you into it. I think the master folder is organic. So if we go, I'm pretty sure it's in organic. Yeah, organic, leaves, miscellaneous, plants, rocks, trees. trees, here's all the trees, okay? Now the ones that come with Moto are basically this one all the way down, okay? All of these other ones, these are special ones that I've gotten in other locations. Adding these mesh presets into your scene is really, really easy, okay? If you simply just double click on them, it's automatically going to place that tree at the origin of the scene, and right now the origin of my scene is on the inside of my building somewhere. Oh, it's way down there. Where's my tree? It's inside my building. Let's move it. It's very small. There it is. It's inside my building. Whee! I don't know why my grid is. There we go. My work plane was set. There it is. Okay. Don't worry about establishing all the materials and textures. So if you use one of the trees that has no leaves, next week I'm going to show you how to put leaves on them. Okay. Modeling trees and bushes is stupid. Okay. So I don't want you guys to do it. Okay. It really is. It really is. It is a monumental waste of our time. Okay. So I want to show you a really cool technique that will allow us to quickly place leaves on all of these kind of skeletons and branches for our trees. It's a really neat thing, and you guys will dig it. Okay. So trees and bushes, explore the mesh preset library. Please, the only thing that you're allowed to use in the mesh preset library are trees and bushes. Okay. Don't use the house. Hint, hint. Nudge, nudge. I know what it looks like. Huh? There's a rhino. You can put the rhino because obviously I know what that looks like and this is not part of the assignment. So if you want to have like a rhino or like the cool little chameleon hanging out at your house, I say do it. There's also a really awesome bug too. All right, real quick, one last thing. Okay, a couple things. In addition, for this assignment for next week, I would like you to render the geometry of your house. So you're still going to make a pretty picture. Please, please, please use one of the exterior HDR reflection maps, those environment maps that we've been using. Exterior. For whatever reason, from time to time, people want their homes to look as though they're inside of a studio. No, we want our homes to look like they're outside. So use the exterior reflection maps when you're rendering this bad boy. Okay? As always, at the conclusion of this assignment, I need your master Luxology project file and the render. Okay? Both of those are due by the beginning of class next week. I've given you some really great examples of the directions students have gone in the past. These are obviously these are more than just the geometry that you're going to be constructing this week, but it kind of gives you a good kind of barometer and direction that you should be heading in. Okay? These are great illustrations of some awesome student work. Okay? This one kind of illustrates what I'm going for when it comes for that small little landscape. We can see the driveway, the sidewalks, the fence. You know how to make these, okay? Use the simple construction tools to generate these assets quickly. All right. Apparently everyone thinks class is over. We have a lab assignment to do. Lab. I'm forcing my hand this week. You have to do some reference, okay? You have to base your entire model in reference this week, okay? I'm not giving you any reference. You have to go out and find the reference online and make a little zipped archive of what you found, okay? So you will be submitting and turning in the collection of images that you find online, okay? Now you're not expected to build the homes and the reference images that you find online, but I would like you to be at least inspired by them, okay? Use the reference images to show you details, to understand how windows look, how the doors look, how the roof and the walls and the different planes within the house are supposed to be generated from each other. If you're lucky, you may find all the blueprints for the home online, okay? That's not impossible to find. At the very least, you'll absolutely be able to find floor plans, finding what's called an elevation. A little bit more challenging, but you can find it if you're creative with your Google searching, okay? You have to do this. I want about 10 or 12 images, okay? Every project is founded in research, okay? We have to look, especially for architectural visualization, our homes need to look real. The only way to do that, beyond any reasonable doubt, got to have it found in reference.
Do we have our own camera?
Yeah, that's fine. If you want to go out and take pictures of your house, even better. Even better. I think that's a great idea. Great idea, okay? One other thing, and this is just kind of a professional suggestion as you work through this project. This is when you're finished with this assignment in a couple weeks, you're going to be producing some renders that look like this. Okay? How far is the camera away from this home? Yeah, it's not like we're all up in there, right? It's not real close. Okay, it's pretty far away from the house. Okay, we're probably, if this is a real world camera and that's a real world house, we're probably 30 feet away from this house. Okay, so with that said, what type of model is this going to be? Is it going to be a polygonal model or a subdivision surface model? Polygonal. Okay, this model you don't need to hit the tab key on. Okay. We're not going to see any benefit from this distance. We're not going to see any benefit of using subdivision surfaces, okay? In addition, if you can't see it from the render, you don't need to model it, okay? About a year ago, I had a guy, and he spent seemingly 40 hours modeling a doorknob for his house, right? And this was an amazing doorknob. I mean, it was super detailed, it was beautiful, it was all subdivision surfaces. And when he was done with his house, I said, okay, great, let's take a render. And all of his renders were of the front door. And I was like, no, 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 no. You're rendering a house, not the front door of your house, the house. He's like, but I put all that time and effort into the front door. And I was like, yeah, well, you wasted your time, okay? You wasted your time because you're modeling a house, okay? If you can't see the detail in a render like this, can you see the doorknob on the house? No. Yes. I can see it. It's 1 pixel, okay? It's 1 pixel. It is a cylinder. It is a rounded out cylinder. That's all it is at this resolution, okay? Don't go crazy with the detail. If you can't see it in the render, you can't see it in the render. I don't want you guys to waste 40 hours making a doorknob that you're not going to see. Spend all your time over the next week focusing on the form, the plane changes, and the solid, accurate construction principles that we talked about today, and you will leave this project with an excellent, excellent portfolio piece, okay? This is the next couple assignments are geared to be portfolio pieces, okay? This is one of them. As a 3D modeler, this is something that you should be able to show someone. You need to be able to show someone that you can make a house, a building, boom, this is the assignment. You need to be able to show someone that you make a product, that's the cell phone next week. A high resolution, glossy product, okay? Cell phone next week. And the third thing you need to show someone is can you make a character, and that's going to come up after that, okay? So the next couple projects are all portfolio pieces, so keep that in mind, okay? Questions on what we're going to be doing for our homework in our lab? Oh, one thing, does everyone know how to make a zipped archive? Let me show you how to make a zipped archive if you're unfamiliar. It's a very similar process on both the Mac and the PC side. What you want to do as you're doing the reference collection, you want to work with a whole series of files or a whole series of specific images. Oops, excuse me. Get rid of this. Okay, so here's a PDF. We're going to pretend that this is one of the images that I downloaded from the web, right? I would put this in a folder. Okay, so new folder, reference. Okay, whee. Okay. Now when you're done with this, take your folder and you want to zip it up. On a Mac, it's really easy. If you just right-click on the folder, you can do compress. And that's going to compress it and generate a zipped file. You have something very, very similar on the PC. It's still in that right-click menu, and I've just, for the life of me, I've forgotten what the actual command is, but it's something very, very similar to compress, or it's like zip or archive or something like that on the PC. I'm not a Windows dude, so I don't really know off the top of my head, okay? When you're finished, that zipped archive is what you're going to be uploading to the web, okay? D2L, no likey the folders, okay? You can't upload a folder. You have to upload a file. This is the best way to take a folder of images and get it into a file, okay? Make sense? All right. All right, we got about 15 minutes left in class. Let's use this time wisely, all right?